In the world of large language models and AI, prompt engineering is the art and science of crafting inputs that effectively guide the model towards the desired outcome. While it may sound like it's all about asking the right questions, but advanced prompt engineering is actually about much more. It involves structuring instructions, defining clear constraints, and aligning with the underlying mechanics of how these models process and respond to the text. This tutorial will take you through the nuances of advanced prompt engineering, delving deep into the process, tools, and techniques to ensure that your prompts trigger the best possible results from AI systems like Gemini, ChatGPT. Now guys, before we move on, here's the agenda of our today's session. First, we are going to understand what exactly is prompt engineering. Then we are going to understand what are LLMs, and then we are going to understand how LLMs are processing and generating the text. And after that, we are going to understand transformers, which are very, very much important to understand how these LLMs actually understand the context. And we are going to implement it with Gemini using Python. So that's a very interesting part. After that, what we are going to do, we are going to create a React app with ChatGPT. And while building this app, I'm going to show you how we are actually utilizing amazing prompts to build that. And finally, we are going to discuss some of the best practices that you should use while creating a prompt. Now, here is a short quiz to test your knowledge. Which of the following is not a key principle of advanced prompt engineering? Your options are structuring explicit instruction for the model, asking open-ended questions to follow flexibility in response, or understanding the underlying model architecture, or providing clear constraints and avoiding ambiguity in the prompts. Now, before we deep dive into our course, here is a short info for you guys. You can elevate your creative abilities with our highly acclaimed generative AI course. You can dive into AI innovation and explore key concepts like generative AI, prompt engineering, ChatGPT, and many more. And you can acquire cutting-edge knowledge to gain competitive edge and advance your career in the evolving AI landscape. And this course is powered by EN ICT Academy of IIT Kanpur. So guys, you can check this course out. Now, let's get started. But before that, I request you that do not forget to hit the subscribe button and click the bell icon. Let's get started. Prompt engineering at advanced level is not about asking better questions. It's about designing instructions in a way that aligns with how large language models process text and prioritize information and make predictions. A prompt is just not a message. To a human, it's a control interface for probabilistic reasoning system. Most people fail at prompt engineering because they assume the model understands the intent. In reality, the model only understands instructions, order, and constraints. When a prompt looks correct but fails, it usually means the human intent was never made explicit to the model. Now guys, in today's tutorial, we are going to discuss why prompts fail even when they look correct. So see guys, a prompt often fails because humans rely on shared context and common sense. When you say something like, make this better, you already have mental definition of better, but the model does not have it. It guesses what better usually means based on past patterns, which leads to generic or misaligned output. Another reason for prompt failing is because of conflicting goals. Humans frequently ask for outputs that are simultaneously short and detailed. They are also creative and factual, casual and professional. The model cannot resolve contradictions unless you explicitly tell it how to prioritize. This is also a hidden assumption problem. Many prompts assume the model knows audience and the platform, the tone, and the depth of the format. If these are not stated, the model defaults to most statistically common version, which usually feels bland or off target. Let me give you one example. Imagine there is a marketing manager asking ChatGPT to write a LinkedIn post about AI in marketing. To the human, this means something specific, like the professional tone, business audience, and actionable insight. And also there is engagement-driven writing. To the model, this is just a vague content request. It responds with a generic explainer style to the post because this is the most common pattern. When you you see it with reference to a ChatGPT, this is actually associated with AI in marketing. So it follows that kind of very generic patterns. Let me show you one good example. Let us open our ChatGPT and let us try to write the given prompt. Write a LinkedIn post about AI in marketing. So let us type that. Now let us try to read the output and see how it is going to sound. So guys, you can see all over here, it says AI is transforming marketing strategies, making them more personalized, efficient, data-driven than ever. And you can see here's how AI is changing marketing landscape. So you can see there is personalized content, predictive analytics, enhanced customer service, automated campaigns, then content generation. And finally, it has given the future of marketing with AI. So as continues to evolve, the role of marketing will only expand from advanced to machine learning algorithm. Now, if you write vague prompts like this, let's say if you have to also write to a particular, let's say word count, then you can see the word count is also very much less. Now, I will show you, try writing this prompt instead of that. Now, let's say you are writing, let's say a LinkedIn post about AI in marketing, and let's say the audience is marketing managers with 3 to 7 years of work experience, and let's say the goal is to spark a discussion, not explain. So let us see the output and try to compare it with the previous one. So you can see it has given AI marketing managers with few years of experience in a bit, probably seen the landscape shift in countless ways. So AI in marketing isn't just about automating tasks. So you can see it has given. Now, even still the word count is pressed. Okay. You can increase the count by asking word count. And let us try to see the given thing. So you can see mostly you have to iterate, but you can reduce your iteration with writing proper prompts. So guys, you can see the output immediately improves because you replaced assumptions with instructions. And this is actually the core idea, that a good prompt removes guesswork from the model. Now, let us try to discuss a question, very important one, like how LLMs actually interpret the instructions. So guys, before diving into Transformers model, let me tell you an interesting story. So in 2017, there was one research paper which was called Attention is All You Need. And if you Google search this, you are going to get this given PDF. So this was the research paper and it came in with reference to ChatGPT. And if you read this research paper, guys, all you are going to understand that this is based on the transformer model of ChatGPT. Now, there is a particular citation, so you can Google search this. Now, you can also find this paper all over here on NIPS papers. So these are the two advisable links. So this actually has been very tremendous advancement. And in this transformative era, we all know that transformers are very much important if you want to understand how LLMs actually work. Let us deep dive into this concept. So guys, let us first try to understand what are transformers. So if I talk about transformers, guys, so they are actually developed to solve a sequence of problems. And basically it could be a sequence of transduction, or it could be a neural machine translation, which means that they are meant to solve any task. Now guys, let us try to first understand what are transformers. See, transformers were first developed to solve the problems of sequence transduction, or you can say neural machine translation, which means they are meant to solve any task that transformers as an input sequence to an output sequence. That's why they are called as transformers. But let us first try to understand what are exactly transformer models. A transformer model is a neural network that learns the context of sequential data and generates new data out of it. To put it simply, transformer is a type of artificial intelligence model that learns to understand and generates human-like text by analyzing patterns in large amount of text data. Transformers are basically a current state of the art of NLP model, and they are considered the evolution of encoder-decoder architecture. However, the encoder-decoder architecture relies mainly on the recurrent neural networks to extract sequential information, and transformers completely lack this recurrency. Now you'd be wondering, how do they do it? They are specifically designed to comprehend context and meaning by analyzing the relationship between different elements, and they rely almost entirely on the mathematical technique called as attention to do so. So guys, first let me show you the transformer architecture. So guys, let us first try to understand what are transformers. Transformers were first developed to solve the problem of sequence transduction or neural machine translation, which means they were meant to solve any task that transforms an input sequence to an output sequence. That's why they are called as transformers. So now another question also pops up, that what are transformer models? See, a transformer model is like a neural network that learns the context of sequential data and generates new data out of it. To put it simply, you can say something like this, that transformer is a type of artificial intelligence model that learns to understand and generate human-like text by analyzing patterns in large amount of data. Transformers are a current state-of-the-art NLP model and are considered the evolution of encoder-decoder architecture. However, the encoder-decoder architecture relies mainly on recurrent neural network to extract sequential information. Whereas if I talk about transformer, they completely lack this recurrency. And you would be wondering now, how would they do it? Basically, they are designed to comprehend context and meaning by analyzing the relationship between different elements, that they rely almost entirely. And it's all on mathematical technique, which is known as attention to do so. Now, let me give you a little bit of historical context also. So this was originated from 2017 research paper by Google, where we got to know that transformer models are one of the most recent and influential developments in machine learning field. The first transformer model was explained in the influential paper, which was known as Attention is All You Need. And this pioneering concept was not just a theoretical advancement, but also found a practical implementation, notably in TensorFlow's tensor-to-tensor package. Furthermore, the Harvard NLP group also contributed to this by offering an annotated guide to this paper, which also supplemented by giving more information about PyTorch implementation. Now, their introduction has also spurred a significant movement in this field, which is often referred to as transformer AI. And this is a revolutionary model which laid the groundwork for subsequent breakthroughs in the realm of large language models, including BERT. And by 2020, researchers at OpenAI also announced GPT-3, and within weeks you can see GPT-3's versatility was quickly demonstrated when people were using it to create poems, programs, songs, websites, and more captivating the imagination of users globally. Now, there was a time in 2021 when Stanford scholars aptly termed these innovations as foundation models, underscoring their foundational role in reshaping AI. Now, if I discuss about today's scenarios, we are in a time where simple methods like neural networks are giving us an explosion of new capabilities. And there is a shift from RNN models to LSTM to transformers for NLP problems. At the time of transformer model introduction, RNNs were the preferred approach for dealing with sequential data, which is characterized by specific order in its input. RNN's function is very similar to a feed-forward neural network, but it processes the input sequentially, one element at a time. So you can see all over here, let's say if we have the input, you can see transformer takes it and sequentially you get the respective output. At a time of transformer model introductions, RNN were the preferred approach for dealing with the sequential data, which is characterized by a specific order in its input. RNN's function is similarly to a feed-forward neural network. That means that it processes the input sequentially one element at a time. Transformers were also inspired by the encoder-decoder architecture which was found in RNN. However, instead of using the recurrence, the transform model was completely based on attention mechanism. Besides improving the RNN performance, transformers have provided a new architecture to solve many other tasks such as text summarization, image captioning, and speech recognition. So now the biggest question arises, what are RNN's main problems and why they become quite ineffective for NLP tasks, or for two main reasons. So basically they process the input data sequentially, one after other. And such a recurrent process does not make the use of modern graphics processing units, which are GPUs, which were basically designed for parallel computation. And this makes the training of such models very, very slow. Now they have become quite ineffective, and also you can see the elements are kind of distant from each other. Now this is due to the fact that information is passed at each step, and the longer the chain is, the more probable the information is about getting lost. That's why, guys, we saw a shift from recurrent neural networks to architectures like LSTM to transformers in NLP, which is driven by these problems. And there is a transformer's ability to assess both of them, taking advantage of the attention mechanism improvements. Now, this actually means that pay attention to the specific words no matter how distinct they are. And it actually boosts the performance speed. Thus, transformer became a natural improvement of RNNs. Next, let us take a look at how transformers work. If I talk about the transformers architecture, so you can see it was basically devised for sequential transduction, or we could say that neural machine translation. Transformers actually excel in converting the input sequences into output sequences. And this was the first transduction model which completely relied on self-attention to compute representations of its input and output without using the sequence. Is the characteristics of the transformer architecture maintained in form of its translation as a simple black box. It would take a sentence in one language, for instance English, as an input, and it can give an output in the another language. So you can see all over here that we are taking one instance of, let's say, how are you, which is in English, and you can see we are getting the output in Spanish. So encoder is going to take this input, decoder is going to decode this, and this is all about the transformer architecture. Now if we dive a little bit, we observe that this black box is composed of two main parts. The encoder, which takes in our input and outputs a matrix representation of the input. For instance, the English sentence like how are you. So the decoder is going to take that and the representation, and it generates an output. For example, output is, however, encoder are stacked with layers of number for each, all in the same each one of them, and this is passed into the next one. Similarly, all the decoders present the same structure as well as and get the input from the last encoder and the previous decoder. So guys, actually the original architecture was consisted of 6 encoders and 6 decoders, but we can replicate as many layers as we want. So we can assume that n layers for each. So now we can get a generic idea of the overall transformer architecture. Now let's try to focus on both encoders and decoders to understand the better part of like how they exactly work. So guys, the encoder is a fundamental component of the transformer architecture. So guys, let us first understand the encoder workflow. The encoder is a fundamental component of the transformer architecture. The primary function of the encoder is to transform the input tokens into contextualized representations. Unlike earlier models that process tokens independently, the transformer encoder captures the context of each token with respect to the entire sequence. Its structure composition consists as follows. So you can see all over here. So as you can see all over here in the given diagram, first one we have the input embeddings. The embedding only happens in the bottommost encoder, and the encoder begins by converting input tokens, words or subwords into vectors using embedding layers. These embedding captures the semantic meaning of the tokens and convert them into numerical vectors. All of these encoders receive a list of vectors, each of size 512, which is a fixed size. In the bottom encoder, that would be the word embeddings. But in other encoders, it would be the output of the encoder that's directly below them. Since transformers do not have recurrence mechanisms like RNN, they use positional encoding added to the input embeddings to provide information about the position of each token in the sequence. Now, this allows them to understand the position of each word within the sentence. To do so, researchers suggested employing a combination of various sine and cosine functions to create positional vectors, enabling the use of this positional encoder for sentences of any length. In this approach, each dimension is represented by unique frequencies and offsets of the wave with values ranging from -1 to 1 and effectively representing each position. Now, in the next step, we can see there is a stack of encoded layers. The transformer encoder consists of stack of identical layers, 6 in the original transformer model. The encoder layer serves to transform all input sequences into a continuous abstract representation that encapsulates the learned information from the entire sequence. And this comprises of two submodules. First of all, we have multi-headed attention mechanism, as you can see all over here. Additionally, you have the fully connected network. And it also incorporates residual connections around each sublayer, which are then followed by layer normalization. Now let us try to discuss a bit about the multi-headed self-attention mechanism. In the encoder, the multi-headed attention utilizes a specialized attention mechanism known as self-attention. And this approach enables the models to relate each word in the input with the other words. For instance, in a given example, the model might learn to connect the word are with you. And this mechanism allows the encoder to focus on different parts of the input sequence as it processes each token. It computes attention score based on a query vector, and which basically what it does is it is representing a specific word or token from the input sequence in the attention mechanism. Then there is a key also in the vector, which is the attention mechanism corresponding to the each word or token in the input sequence. Each value is associated with a key and it is used to construct the output of the attention layer. When a query and a key match well, which basically means that they have the high attention score to the corresponding value and it is emphasized in the output. This first self-attention module enables the model to capture contextual information from the entire sequence. So instead of performing a single attention function, queries, keys, and values are linearly projected each time. On these projected versions of the queries, keys, and values, the attention mechanism is performed in parallel, yielding h-dimensional output values. Once the query, key, and value vectors are passed through the linear layer, a dot product of matrix multiplication is performed between the queries and keys, resulting in the creation of score matrix. And the score matrix establishes the degrees of emphasis each word should place on the other words. Therefore, each word is assigned a score in relation to the other words within the same time step. A higher score indicates greater focus, and this process effectively maps the queries to the corresponding keys. Now guys, let us try to discuss a bit about normalization, meaning reducing the magnitude of these scores. The score can be scaled down by dividing them with the square root of the dimension of the query and the key vector. This is kind of a mathematical step, and this step is implemented to ensure more stable gradients, as the multiplication of values can lead to excessively large effects. Then you can apply a softmax function to the adjusted scores to obtain the attention weights. And this results in probability values ranging from 0 to 1. The softmax function emphasizes higher scores while diminishing lower scores, thereby enhancing the model's ability to effectively determine which words should receive more attention. Now guys, you can combine softmax results with the value vector. In this following step of the attention mechanism, the weights is derived from the softmax function and then are multiplied by the value vector, resulting into the output vector. In this process, only words that represents high softmax score are preserved. Finally, this output vector is fed into a linear layer for further processing. Now guys, as you can see in this diagram, you are going to get the output of the attention mechanism. And you might be wondering why it's called multi-head attention. First of all, I would like to make you remember that before all the process starts, we break our queries, keys and values H times, and this process is known as self-attention, and it happens separately in each of these smaller stages or heads. Each heads work its magic independently, conjuring up an output vector. This ensemble passes through a final linear layer, much like a filter that fine-tunes their collective performance. And it's kind of very amazing to see that there is a diversity of learning across each head, which is actually enriching the encoder model with a robust and multifaceted understanding. And then you proceed for normalization, guys. So guys, in the normalization layer, each sublayer is an encoder layer followed by a normalization step. Also, each sublayer output is added to its input, which is residual connection, to help mitigate the vanishing gradient problem, which allows deeper models, and this process will be repeated after the feed-forward neural network too. The journey of a normalized residual output continues as it moves through point-wise feed-forward network, which is kind of a crucial phase for additional refinement. Now picture this. Here you have a network of duo linear layers, and with a ReLU activation, so it's also activation method, which is nested in between them, and this is actually acting as a bridge. The reunion is followed by another round of normalization, ensuring everything is well adjusted and in sync for the next steps. The output of the final encoder layer is a set of vectors, each input sequence with a rich contextual understanding, and this output is then used as an input for the decoder in the transformer model. This careful encoding paves the way for the decoder, guiding it to pay attention to the right words in the input when it is time to decode. Think of it like building a tower where you can stack up n encoder layers, and each of this stack gets up a chance to explore and learn in the different facets of attention, much like layers of knowledge. And this not only diversifies the understanding, but could significantly amplify the predictive capabilities of the transformer network. Now let us try to decode the decoder's workflow. The decoder's role centers on crafting text sequences mirroring the encoder, and the decoder is equipped with similar set of sublayers. It boasts two multi-headed attention layers, which is kind of a point-wise feed-forward layer, and it incorporates both residual connections and layer normalization after each sublayer. So guys, these components function in a way which is kind of very compatible with the encoder layers. But there is a twist. Each multi-headed attention layer in the decoder has its unique mission. The final output of the decoder process involves a linear layer serving as a classifier with a words. Trying to generate this output by decoding the encoded information step by step. It is kind of important to notice that the decoder operates in an auto-aggressive manner, like kick-starting its process with a start token. It cleverly uses a list of previously generated outputs as its input, and the output which you get from the encoder are rich with attention information from the initial input. This sequential process of decoding continues until the decoder has reached a pivotal moment, the generation of token that signals the end of its output creation. Now, if you could see on the output embeddings at the decoder's starting line, the process is mirroring that of encoder. So here is the input first, which passes through the embedding layer. After following the embedding, again just like the encoder, the input passes by the positional encoding layer. And this sequence is designed to produce positional embeddings. These positional embeddings are then channeled into the first multi-headed attention layer of the decoder, where the attention scores specific to the decoder's input and are meticulously computed. The decoder consists of a stack of identical layers, for example 6 in the original transformer model, and each layer has 3 main subcomponents. Now if I talk about the masked self-attention mechanism, this is kind of very similar to the self-attention mechanism in the encoder, but with a crucial difference. It is preventing the positions from attending to subsequent positions, which mean that each word in the sequence isn't influenced by future tokens. For instance, when the attention scores of the word R is being computed, you can think something like this. It is important that the word R doesn't get peek at you, which is a subsequent word in the sequence. The masking is ensuring that the predictions for a particular position can only depend on its own output at positions before it. Now if we talk about the encoder-decoder multi-head attention, in this, the multi-headed attention layer of the decoder, we see a unique interplay between the encoder and decoder components. Here the outputs from the encoder take on the roles of both queries and keys, while the outputs from the first multi-headed attention layer of the decoder serves as value. This setup actually effectively aligns the encoder inputs with decoders, empowering the decoder to identify and emphasize the most relevant parts of the encoder input. And following this, the output from this second layer of the multi-headed attention is then refined through pointwise feed-forward layer, enhancing the processing further. Now, if you see in this sub-layer, guys, the queries come from the previous decoder layer and the keys and the values from the output of the encoder. And it is actually allowing every position in the decoder to attend over all positions in the input sequence, which effectively integrates information from the encoder with the information in the decoder. Similar to the encoder, each decoder layer includes a fully connected feed-forward network, and it is applied to each position separately and identically. Then if we talk about the journey of a data through the transformer, model culminates its passage through the final linear layer, which functions as a classifier. The size of the classifier corresponds to the total number of classes involved. For example, the number of words contained in the vocabulary. For instance, in a scenario with 1000 distinct classes representing 1000 different words, the classifier's output will be an array with 1000 elements. The output is then introduced to a softmax layer, which transforms it into a range of probability scores, each lying between 0 and 1. And as you already know, guys, that the highest of these probability scores is the key, and the corresponding index directly points to the word that the model predicts as the next in the sequence. Then what happens, guys, each sublayer, which is actually trying to relate to the masked self-attention mechanism and also encoder-decoder attention, and also using feed-forward network, it is followed by a normalization step. And each of these also includes a residual connection around it. The final layer's output is transformed into a predicted sequence, typically through a linear layer followed by the softmax to generate probabilities over the vocabulary. The decoder in its operational flow incorporates the freshly generated output into its growing list of inputs, and then it proceeds with the decoding process. This cycle repeats until the model predicts a specific token, signaling the completion. So as you can see all over here, then the token is predicted with the highest probability and it is assigned with the concluding class, which is often represented by the end token. Again, remember guys that the decoder isn't just limited to the single layer. It can be structured with n layers and each one building upon the input received from the encoder and its preceding layers. This layered architecture allows the model to diversify its focus and extract varying attention patterns across its attention heads. Such a multi-layered approach can significantly enhance the model's ability to predict as it develops a more nuanced understanding of the different attention combination. And you can see the final architecture somewhat just looks like this. To better understand this architecture, guys, what I can say you, try to see the documentation where you are building a transformer using PyTorch. Now let us discuss some of the transformer models. Let us first talk about BERT. So guys, BERT is an open source natural language processing framework which actually revolutionized NLP with its unique bidirectional training. And it enables the model to have more context-informed predictions about what next word should be. And also guys, by understanding context from all the slides of a word, BERT outperformed previous models in tasks like question answering and understanding ambiguous language. Now, its core uses transformers connect each output and input element dynamically. BERT is also pre-trained on Wikipedia and it excelled at various NLP tasks like prompting Google to integrate it into its search engine for more natural queries. Actually, this innovation sparked a race to develop advanced language models and significantly advanced the field's ability to handle complex language understanding. To know more about BERT, what you can do is you can check this respective documentation all over here, and it is given by Hugging Face. There is an amazing thing you can see all over here how the respective things are being done, like creating a pipeline, the BERT configuration, like vocab size, hidden size, num hidden layers. So these are the respective thing. What are the parameters? You can expand and learn about the respective parameters. Now let me take you to these parameters one by one. So if I talk about BERT, guys, so you can work on vocabulary size, hidden size, then number of hidden layers, the number of attention heads, then intermediate size, hidden act, hidden dropout probability. Then you can find out attention probability, dropout probability, then maximum position embeddings, type vocabulary size, initializer range, layer norms APS, its decoder, use cache, classifier, dropout. So these are the respective parameters and you can read about it all over here. Then you will also know a little bit about what is BERT tokenizer and how to construct it. Then there are 9 parameters. So it's a kind of a pretty detailed thing where you are going to get a little bit more into tech side this is, but you can see what are the important tech things this LLM is actually taking it into the consideration. Now let us also discuss about another LLM, which is Lambda, which stands for Language Model for Dialogue Application. And this is also a transformer-based model which is also developed by Google. And it is designed specifically for conversational tasks, and it was launched during 2021 on the Google I/O keynote. They are designed to generate more natural and contextually relevant responses, enhancing the user interactions in various applications. Lambda's designs enable it to understand and respond to a wide range of topics and user intents, making it ideal for applications in chatbots, virtual assistants, and other interactive AI systems where dynamic conversation is the key. This also focuses on conversational understanding and response marks Lambda as a significant advancement in the field of natural language processing and AI-driven communication. Now, if you are interested to further understand the Lambda models, you can get better understanding with this article. All over here, you can read this about Lambda. So it's already present, like how Lambda came into existence and how it was competing with the other model like BERT and GPT-3. Now let us go through another model which is called as ChatGPT, and it is very much popular. Built and developed by OpenAI, it is an advanced generative model and known for its ability to produce coherent and contextually relevant text. GPT-1 was its first model, which was launched in June 2018, and GPT-3 is the most impactful models which was launched in 2020. These models are adept to a wide range of tasks, including content creation, conversational language translation, and many more. GPT's architecture enables it to generate text that closely resembles human writing, making it useful in applications like creative writing, customer support, and even coding assistance. ChatGPT, which is a variant and optimized for conversational context, it excels in generating human-like dialogue, enhancing its application in chatbots and virtual assistants. So guys, the landscape of foundational models, particularly the transformer models if I talk about, is actually rapidly expanding. And there has been a very thorough study which identified over 50 significant transformer models. While the Stanford University also evaluated 31 of them, acknowledging the field's fast-paced growth. NLP, which is an innovative startup part of NVIDIA's Inception program, it has utilized 25 language models commercially for various sectors like airlines and pharmacies. There is also an increasing trend towards making these models open source, which makes these platforms like you can see Hugging Face Model Hub and ChatGPT, which are kind of leading the today's rate. And also Gemini has also come up into the picture. And you can see there are amazing LLMs which are developed by Google. But now everything has been integrated into Gemini, and Gemini is one of the most popular, and it has also excelled in various benchmarks. You can also look for Anthropic's Claude, which is also making huge waves in the LLM field. Now, if I talk about benchmark and performance, benchmarking and evaluating the performance of a transform models in NLP involves a systematic approach to assess their effectiveness and efficiency. Depending upon the nature of the task, there are different ways and resources to do so. First, if I talk about machine translation tasks, let's say for example, when you're dealing with machine translation tasks, you can take advantage of standard data sets like from workshop on machine translation, where empty systems encounter a tapestry of language pairs and each offering its unique challenges. So you are going to see metrics like BLU, Meteor, Tier, which actually is serving as a navigational tools, and it guides them towards accuracy and fluency. Additionally, if I also talk about testing across diverse domains like news, literature, and technical text ensures an empty system's adaptability and versatility, which makes it a true polyglot in the digital world. Now guys, if I also talk about if you want to evaluate these respective models, then you can use a special collection of question and answers. Like there is something called Squad, which is Stanford's question and answering dataset, or natural questions or trivia's question answers. Now each one of them is like a different game with its own rule. For example, if I talk about Squad, it is all about finding answers in a given text, while others are more like a quiz game with questions from anywhere. To see actually how well these programs do, you can use scores like precision, recall, F1, and sometimes even exact match scores. Now, when dealing with natural language inference, you can also use special datasets like SNLI, which stands for Stanford's Natural Language Inference, or multi-NLI or NLI dataset. Now, what are these? Basically, these are like a big libraries of language variations and tricky cases, which helps them to see how well the computers understand different kinds of sentences. And they mainly check how accurate the computers are in understanding if a statements agree or contradict, or they can be unrelated. So it's kind of very much important to look into how computer figures out tricky language stuff. And it's like when a word refers to something, as mentioned earlier, or understanding not at all or some of it. So you can look into that. Now, if you think in the world of neural network, two prominent structures are usually compared to transformers. And if I talk about it, each one of them offers distinct benefits and challenges. And these are tailored for specific types of data processing. RNNs, which already appeared throughout in our given conversation, and also we talked a bit about convolutional neural layers. Now, if I talk about recurrent layer, guys, it is actually the cornerstone of RNN, and it is excelling in handling sequential data. Now, this architecture's strength lies in its ability to perform sequential operations, which are crucial for tasks like language processing or time series analysis. In a recurrent layer, the output from a previous step is fed back into the network as input for the next step. And there is a looping mechanism which allows the network to remember previous information, and it is very much vital in understanding in a sequence. But as we have already discussed, that the sequential processing has application. Now what it can do is it can lead to longer training time since each step depends upon the previous one. Now it makes the parallel processing challenging kind of, but these often struggle with long-term dependencies due to the vanishing gradient problem, where network becomes less effective at learning from the data points. And these are far apart in the sequence. Generally, if I talk about these transformer models differ significantly from architectures using recurrent layers, as they lack recurrency. And as we have seen before, the transformers attention layer assesses both problems, making them natural evolution of RNN for NLP applications. Now let us discuss a bit about the convolutional layers. So guys, if I talk about the convolutional layers, these are the building blocks of convolutional neural networks. And these are renowned for their efficiency in processing spatial data like images. Now these layers can use kernels, or we call it as filters, which basically scan over input data to extract features. And the width of these kernels can be adjusted, which allows a network to focus on small or large features depending upon the task at hand. While convolutional layers are exceptionally good at capturing spatial hierarchies and patterns in the data, they face challenges with long-term dependencies. They do not inherently account for sequential information, which makes them less suitable for tasks that require understanding and the order or context of a sequence. And this is why CNNs and transformers are tailored for different types of data and tasks. CNNs dominate in the field of computer vision due to their efficiency in processing spatial information, while transformers are a good choice for complex sequential tasks, especially in the NLP, due to their ability to understand long-range dependencies. Now, after having a very good discussion on transformers, because it's kind of very much important to understand this architecture, such that you have a bit of clarity like how your LLMs are working, and from there you can move on to the prompt side and think about it, how these model effectively takes your prompt. So, by effectively managing sequential data through their unique self-attention mechanisms, these models have outperformed traditional RNNs, and their ability to handle long sequences more efficiently and also parallelize data processing significantly is accelerating their training. Some of the models have done great, like Google's Gemini, OpenAI's GPT, and they are actually and also I would like to mention Claude, which is exemplifying transformative impact of transformers in enhancing search engine and also generating human-like text. Now, as a result, they have become indispensable in modern machine learning, which is driving forward the boundaries of AI and opening new avenues and technological advancements. Now, guys, let us move ahead and try to move in a direction where I would teach you how to build transformers with Python's own library, PyTorch. Now, guys, let us implement the transform model using PyTorch. So guys, PyTorch is a library, and building the transformer model with PyTorch, and also guys, we are going to train the PyTorch transformer model all over here, and we are going to evaluate the model performance also. So guys, as I have already told you about transformers, that it actually came up with the paper, Attention is All You Need. And transformers have since become a cornerstone of many NLP tasks due to their unique design and effectiveness. Now, at the heart of transformer is the attention mechanism, which has a very special concept, self-attention, which we discussed a couple of minutes back. And it also allows the model to weight and prioritize different parts of the input data. This mechanism enables transformers to manage long-range dependencies in data. It is fundamentally a weighting scheme that allows a model to focus on different parts of the input when producing the output. So guys, the self-attention mechanism allows the model to consider different words or features in the input sequence. And also it assigns each one a weight that signifies its importance for producing a given output. For instance, in a sentence translation task, while translating a particular word, the model might assign higher attention weights to the words that are grammatically or semantically related to the target word. And this process allows a transformer to capture dependencies between words or features, regardless of their distance from each other in the sequence. And we have already seen that transformers has an amazing impact in the field of NLP, and you cannot overlook that. It has outperformed traditional models in many tasks, and it has demonstrated a superior capacity to comprehend and generate human language in more nuanced way. And guys, in this advanced prompt engineering, we are going to use the AI also to create the transformer. The library that we'll be using is Python's library, that is PyTorch. And before we start building a transformer, let's try to set up the working environment. So you can see I am using Google Colab all over here. And first and foremost, PyTorch needs to be installed. So you can install it through pip or Conda package managers. It also depends upon the IDE. So I will be using pip to install all over here. And you can use this respective command. So guys, type all over here pip3, and then what you can type is pip3 install, and you can type something like torch. Then you need to type torch vision. Okay. Then you need to put torch audio all over here. Now let us click enter, and you can see it is trying to connect to the Google server. We'll wait for a couple of time. Okay, you can see some syntax issues happening with some word. Let us correct this. Now guys, as you can see all over here, it's still showing the error. Now let us take the help of the inbuilt agent that we have, which is Gemini, and let us ask it to install, PyTorch. So I'll just going to say pip3 install torch vision torch audio. So you can see it's because pip3 install is a shell command, you need to prefix. So what I'll do all over here, I'll just type give me the correct command. Now let's click enter, and whenever we are going to encounter any issues, we're going to ask the agent. Now you guys would be wondering that how our software development is actually progressing, and you are going to find that with respect to different IDs, sometimes pip3 works. Since it's hosted by Google servers, so pip3 it's not acceptable, and you can see our agent has respective code. So let us try to copy this, so you can see, explain the error also, that so you can just see accept and run, and automatic code will be pasted. Amazing guys. So this is one of the core integration of using LLM in your given IDE or notebook. Now we have successfully installed our PyTorch all over here, and if you want to use Conda guys, and Conda you should not use it here. You can use Anaconda distribution for Python if you want to do that. So what you can do is you can use Conda, and then you can install PyTorch, then PyTorch Vision and -c as a flag, and then PyTorch. But make sure that you have Conda distribution installed on your system. So let's try to install that. Conda install, let's say PyTorch, and then you can add torch vision all over here, and -c and then you can add the PyTorch. Make sure to follow this if you have the Conda distribution. Now let us move ahead to the next part. So guys, for other options for installing and running PyTorch, you can refer to the official website of PyTorch. So just go all over here, and this is going to be your official website of PyTorch, and you can explore this. There is amazing documentation about it, and you can install it and run it on your system. Now this is the official website, so I would advise you to go through it once. And but also I would say it's kind of pretty amazing that you should have have a basic understanding of deep learning concepts. So that's kind of very much important when you are building the transformer. And we'll be using an LLM to build this given transformer. And for those who need a refresher, we have got a deep learning course at our official YouTube channel. You can get a look at it, and if you are kind of a beginner. Now let's try to build a transformer model with PyTorch. Okay, we'll follow these respective steps. So first of all, we need to import the libraries and the modules, and then we'll move ahead with defining the basic building blocks which we had discussed earlier, like the multi-hit attention, position-wise feed-forward networks, positional encoding, and building the encoder block, and then we are going to build the decoder block as per our architecture as we have discussed. Then we are going to combine the encoder and decoder layers to create complete transformers network. Now let us try importing the necessary libraries and modules. So we'll start by importing the PyTorch library for core functionality, and the neural network module for creating the neural networks. Then we'll going to import the optimization module for training the networks, and we are going to use the data utility functions for handling the data. Additionally, what we can do is we'll import the standard Python's math module for mathematical operation, and the copy module for creating copies of complex objects. So guys, this tool is going to set the foundation for defining the model's architecture, managing data, and establishing the training process. So let us start all over here. So guys, let us import Torch first. Type import, and then you can type Torch all over here. Then next thing what we can do is we can import, you can see it has started giving some suggestions, but still we need to import certain things. And one thing I would also like to tell you that when I just talk about using LLMs inside your notebooks, or using an agent inside your notebook, it might not always give the correct suggestion for you, because let's say if anything new technology comes up and you want to refer to that, let's say recently, let's say there might be a new update in the Azure Databricks, and you need to actually look onto that, and it becomes kind of pretty vague, and we will not be able to do that. Now let us move ahead and do the next part. Now we are going to import all over here. So what we can do, I could write torch.nnn, okay, as NNN. And next we have to also import Optim, and we are going to get it from all over here, and you can see we are getting amazing suggestions. So just click the tab, and we will not be using Torch and functional, so we can just end this. Next thing what we could do is we can import torch utils.data. So type import, then you can type torch and dot utils, and you can just type dot data, and you can keep it as data. Next thing, we need to also import math, all over here. Then you can also import copy, and these are the respective libraries that we need to import. Now guys, let us define the basic building blocks. The basic building blocks, as we had discussed earlier, that we need multi-headed attention, position-wise feed-forward networks, positional encoding. And before we get into building our components, we are going to take a look at the following table, which is going to describe the different components of the transformer and their purpose. So first of all, let us try to understand the respective thing, which is multi-headed attention. So guys, let me type this, multi-headed attention. Now next thing what we need all over here is the position-wise feed forwarding network and positional encoding. So let's mention it such that we don't forget. So we can type position and wise, let's say, feed forward. Next thing what we could do is we could type positional encoding. And now before we get into building our components, we are going to look at the following things, and it is going to describe different components of transformers and their purpose. So let us proceed ahead. So if I discuss about the multi-headed attention mechanism, so this mechanism actually is there to focus on different parts of the input, and this is going to capture different positions in the sequence, and also forward networks position wise as a fully connected layers, and then it could transform the attention outputs, adding complexity, positional encoding. Also guys, this is going to add the positional informations to the embeddings. It is also going to provide the sequence order context to the model layer normalization, and we are going to normalize the input to each of the sublayer, which is going to stabilize the training, and it is going to improve the convergence. So if you just look at into this respective diagram, so this is the architecture we are actually trying to build, so which is going to basically improve our residual connections, and also it is going to help in training deeper networks by minimizing gradient issues. Now if I talk about this, there might be some issues all over here. There might be some random network connection. There will be random zeros also, which is actually trying to prevent the overfitting by regularizing the model. So we need multi-headed attention, and this is going to compute the attention between each pair of the positions in the sequence, and it is going to consist of multiple attention heads, which is going to capture different aspects of the input sequence. Now if you see in this given diagram, we have the multi-headed attention. Now let's try to define the multi-headed attention. We are going to build a class for that, and we are going to define the respective methods. So let us try this on Colab. Go down guys. So what you can do, you can type class and then create multi-head attention, and you can see it has automatically given us the NN module. Go down guys under this and let us create a function. So you'd already be aware about this. We create a function with the def keyword, and we need init self model. Just click the tab. So first is self, which is attaching to the instance of this class. Then we have d model, okay, and we have the number of heads available all over here. And we are trying to use the super keyword because it's a concept of inheritance, where we are actually trying to use the constructors of our parent class as all over here. So we have used this multi-head attention class. So all these parameters will be automatically instantiated. Now let us move ahead to ensure the model dimension. Now we need to also make sure that the d-model is divisible by the number of heads. And for that, what we need to do is, so we need to make sure that assert d model num, okay. So if I just write all over here, so what I mean to say, so guys, what I mean to say all over here, that assert model, so I can take this something like this, and you can take assert the model, and we will know that this remainder should turn out to 0. So this modulo, let's say num heads, this should be equal to 0. Now we need to also make sure that the D model must be divisible by number of heads, and that's why we need to assert this all over here. So let's start by initializing the dimensions first. So go all over here. We can make this a little bit upside so that it does not hide our, okay, I don't think so we could move it. Okay, this will be on this side only. Fine. Now go all over down. So from here, let us type a comment which is like initializing the dimensions. Okay. Now what we can do all over here, we can write something like self, okay, dot D model, and it has started giving suggestions. Just click on tab. So you can see self.d model equals model, self.numheads equals to numheads. Now you can see I think there's some indentation issues there. Let's try to correct it. Okay, let's see what is the issue. Click on view problem, and you can see the indentation issue is coming up. So what we can do is we can use the, and just keep it inside. This should come under def. Then similarly all over here, need to push this thing. So we can just do something like this. Now this is pretty much correct. Now guys, what we need to do is we need to find the dimension of each head key, query and value. So what we can do is we can write something like, we can write self dot, let's say the variable is d-k and it is assigned to D model, and this is the num heads, and D value equals to D model. This is also coming for the given respective value. So all these are related, these dimensions are related to the model, but we are just going to only need the key for now. So what we can do is we can comment this out. Now we need linear layers for transforming the input. So what we can do all over here, so we need to instantiate that also. So you can see it's saying self.wq equals to nn linear. So this will be used for transforming the input. Basically what I can say, this is for query transformation. Then what you need is you need a key transformation also. So what we can do is self w.k nn linear, and this becomes the key transformation. Similarly, what you can do is you have to make for the value transformation also, but there is a specific thing that you need to use. So what things you can change all over here. So instead of this, let us try to add the respective thing all over here. So D hyphen model, and we can keep D hyphen model. Okay. Now then you can put all over here. Okay, let's correct this. Okay, some issue is happening. Now let us try to paste this at the end, and here you can add the respective thing. So what you can type here is again the same thing, D hyphen model, and you can type D hyphen model. Then similarly what you can do is you have to also attach it to the respective value. So you can take it as D hyphen model all over here, and D hyphen model. So this becomes our respective value transformation. Now similarly you have to do the transformation also. Now how you could do it? You can just tab, and you can see it has given us self dot wo, and in linear d model. So this is the respective arguments that we'll be using across all over here. Then guys, we need a scaled dot product attention mechanism where we are going to put these variables, query, keys and values. And we have to also make sure that we have to put mask as none. So what you need to do is you need to create a function all over here. So that function could be def scaled dot product attention, and you can use these respective keywords, which is self, and you have the respective q, you have the respective key and values. Now also make sure that you have put mask equals to none. Now we need to also calculate the attention scores. So let us make a comment so that we don't miss out. So calculate attention scores. Okay. Now how to calculate attention scores? So you can see, okay, this is gone. Let's try to keep, okay. So click on tab and you're going to see we have to type attention hyphen scores, and it is given torch mat mul function multiply function, and we are basically transposing it to the respective thing. So basically -2 and -1 are the respective transformation which we are trying to do. So this is how we are calculating the attention scores. Now there is a specific mechanism that I'm going to discuss about how these attention scores are created. So guys, let's I'll just mention it all over here. Okay, it says that we don't miss out, and at the end we are going to discuss like how this respective mathematical functions are coming up into our consideration. But first let us try to see the process. Let us try to justify the architecture that we have studied earlier. So I'll just mention this all over here, that attention scores, and you can see justification methodology. Now we have to also make sure that in this we have to also apply the respective mask if provided, if it is useful for preventing attention to certain parts like padding and all. So we're going to start with a conditional all over here, and we'll make sure that if there is no masking, then we can give attention scores and we can fill it with mask 0 and LE9. So what you can do all over here, just type if, so you can see it is a very set technique. So if mask is not none, you give attention scores, and here you add attention scores dot masked fill all over here, and you can give something like mask hyphen, this could become 0, and this could become LE9. Now guys, let's say if you're not able to understand this respective line, so you can ask the Gemini also. So you can see, let's type prompt explain, and you can see it is going to also explain you, and this is the most beautiful part of coding in modern AI era, that if anything you don't understand, you can just ask the agent. And 80% since these are very traditional things, these are very set templates, so they will have a good amount of training data such that they are going to easily explain you. Now if you could see all over here, let's say I didn't know this respective line, what is mask, what is 1E9. So you can see it says this line of code, then there is attention scores dot mask fill, mask is equals 0 and -1E9 is actually crucial for implementing masking in attention mechanism. Now it says mask equals to 0, so this basically this part identifies the position of the mask where the value is 0, and in the attention A0 typically indicates the position that should be ignored, and this could be like padding tokens in a sequence. So like pretty decent it is giving. And then you can see we have used this function called masked fill function, and this is basically a PyTorch function, and you can see it says that it it takes the attention score tensor and it replaces with the value minus 189, which is basically kind of an exponential value, and it is kind of very, very large negative number. So if this is going to be filled up for all the position where mask is equals to true. So this is pretty interesting. Now it has also explained us why is this happening. So when these attention scores are passed through a softmax function, so what is happening? So basically it is typically turning the scores into probability. So E of minus exponential of 189, so this value becomes very small. So this is essentially becoming a 0. So let's say if the value of E is, so as we all know, the value of E is 2.17 something, and when you divide by 1, so it's kind of a reciprocal in the sense, and 1 by 2.7 and some big large number. So basically, as the number big is there in the denominator, your value is going to transcend it to somewhat nearby 0. And this is a very basic mathematical concept. Even on the graph, if you would see, let's imagine that this is the xy plane, and the graph of E by x is something like this. So basically it passes through, there is a pointer all over here which is 0, and your graph is like a curve, is exponential curve, which as the value increases, your graph reaches for the infinity. Now it is 0 at the point 0, 0. Now, if I just talk about that in that regard, let's say we reverse this. If we take the mirror image of this, so it is going to go down. And this is the exact graph for the negative e to the power negative. So as soon as the value is increasing, the value is dipping down to 0. So just it goes nearby in let's say very, very large number, so the value dips down to 0. So it's something like this. It's a kind of a mirror image of this, and that's also pretty interesting. These are the very basic calculus concepts. So it's mostly, if I have my analysis says the machine learning part, the deep learning and all this, these are all mostly calculus. And what you are doing is the basic coding to automate the thing or try to give instruction to the computer. Now let us move ahead and try to understand the next thing, why this is done. And this is also pretty interesting. So it says when these attention scores are later passed through a softmax function, it is typically turning the scores into probabilities. So there is a function, softmax function. So this is a very important function which is actually applied or used to obtain the attention probabilities, and because in this given model, while building the transformer, we'll be needing the attention probabilities. So that is kind of very much important, and it also says that this is kind of very effective. And guys, this is also showing that this is effectively ensuring that these marks position will be having 0 attention weight. Now this is going to prevent the model from attending the irrelevant parts of the input like padding or future tokens in decoder. Kind of pretty interesting, guys. Now guys, let us try to apply the softmax function. So what you can do all over here, give the attention probabilities. So make sure this is not under this is outside the if block. So after this is there, you have filled this, and then you are so type ettn and then hyphen props, and what you can do all over here is you can just type torch and you can apply the softmax function all over here, and you can give the respective attention scores. And let's say the dimension as -1. All over here. Now after this, we are going to multiply the values to obtain final output. And before that, let us also try to ask the question to the Gemini. Let's say if you don't know why this value is coming as -1. So you can ask the GPT, like, why this dimension is coming -1. So let us wait for the Gemini to give the output. So guys, you can ask everything with this agent. So you can see dim equals to -1 is an argument in this respective function, and it says that it should be applied across the last dimension of the attention scores in the tensor. And that's why dim equals to -1 is typically used for attention probabilities. So this is a concept of normalization, and basically in our multi-hit attention, it says that the attention scores represent how much every each of the query token attends each of the key token, because that's how you are going to match the respective value. And if you want to normalize these scores, you have to use the probabilistic distribution across it. So you have the structure of attention score. So if attention scores has a shape, let's say if you have the batch size, number of heads, the query sequential length or the key sequential length, so you can easily apply the softmax function along with the last dimension. Let's say you have the respective key sequence length, and it also ensures that for each of the combination of the batch size, num heads, and let's say query sequence length, the attention probabilities will be spatially distributed across key sequential length position. And this is making sure that a very basic concept about probabilities, that all these probabilities should be added and they should be equal to 1. And this is very much important. So there is also third option of which says that -1 we are using because of the flexibility. Now this is a very traditional set practice, kind of a very set template. So and we generally use it in PyTorch, and that's why your agent is showing, because it is being trained on the traditional data very much. And it says that because it is making the code more robust to changes and of its respecting preceding dimensions. For example, let's say if we add or remove dimension or head, so there what we could do is we could refer the respective thing, so regardless of how many dimension our respective tensor has. So I hope so you would have got the idea now why we are using dimension equals to -1 all over here. Now let us move ahead and multiply the values to obtain the final output. So guys, what you can do all over here, let's say hyphen multiply by values, and let's say, so what you can do all over here, you create a, so you can see it has already given us a suggestion that output equals to torch.mat multiply function, and we have used the attention probabilities and the values, and finally we are returning the respective output. So you need to understand one thing, guys. Whenever you are working through any architecture, it could be anything. Let's say if you are creating any backend application on any REST API, or any you're trying to code certain architecture, it's very important for you to remember it in step by step. So that's why writing and practicing by writing the comments is very much important. And when you are actually understanding that this is the next step, you can easily integrate the LLM in your codes. So let's say Gemini we are using right now. So with the help of Gemini, you are already going to get the output, and you can see I didn't have to do anything. It just just wrote the comment, because I'm pretty much familiar with this step, and you can see we are getting the respective output. Now let us move to the next step. Now guys, it's time to reshape the input such that we have the number of heads for multi-head attention. So what we can do is we can define a function dev split, and let's give it as hyphen heads. Let's talk it about self x, and let's try to instantiate it. So what we could do it all over here. So let's take the example of batch size, sequential length, and D model. These are the very important variable. So let's type batch size, sequential length, then we can take D model, and we can assign this to x dot size. And after this, what we can do is we can return the respective thing. So we can just call it as return x dot view, and here we can add the respective batch size, sequential length, then we can assign self num hyphen heads, self dot d hyphen k, and we could transpose this respective thing. Now after this, just type dot all over here and transpose it. We can use a transpose function and we can have it 1 2. Now it's better that we keep it in the next line. Okay, some indentation issues happening. We can keep it all over here. Let us move to the next line. Now this is a very much important function because we have to reshape the input all over here so that we have the number of heads for multi-headed function. And that's why, guys, we are using these respective variables: batch size, sequential length, D model, and we are using the size function. So across the x axis we have the respective batch size, sequential length, and we are transposing into the 1 and 2. So these are the respective transposition function. Now if you don't know about transpose function, let's say, so one thing, either you could go to the PyTorch and refer to the official documentation, but also you don't need to do that. Simply you can give a reference all over here. Let's say explain, let's say transpose function, and we can wait for some time. It is going to give us the respective output. So guys, you can see all over here the transpose function that PyTorch, it could use to swap the dimension of a tensor. So let's say if you say -2 -1, so this is swapping the last 2 dimension of the tensor k. So basically says if k has a shape size of batch size, sequential length, D model, and after the linear transformation and linear splitting heads, it becomes batch size, num head, sequential length, and D of k. So this is going to swap the sequential length and dk. This is essential for scale dot product attention by x dot view. So it's telling a lot of technical. What you can do, one more thing, guys, let's say explain in very easy words and provide a real-time example. So you can see, it has given one data. Let's say we have day and sales. Let's say on Monday the sales was 100, on Tuesday the sales was 120. And let's say the table has 2 columns, day and sales. So when you transpose this table, you can essentially flip the rows in the column. So now it becomes sales and Monday and respective day, Tuesday. So earlier it was day and sales. Now this is transposed to this. Notice how day became the row header and sales become the your common. So guys, it says notice how it actually came into the existence. So you can see the day that we have all over here. Let's say the days are Monday and Tuesday became column, and the sales became the row header. And in this code, what basically we are trying to do, we are transposing the same thing. Let's say for numbers or data arranged in a grid like spreadsheet, so tensor or something like that. And now it has given us one example that's kind of pretty interesting. Let's say we have this matrix 1 2 3 4 5 6, and it says that this is a 2 cross 3 matrix. And let's say if we want to transpose this matrix, the first element of each row becomes the first column. So very simple mathematical concept which you might have studied in high school. So similarly, we are trying to do the same thing. Now guys, let us also try to add something. So let's say this is contiguous function, and after that just click on tab and you're going to get the view is all over here. Okay, and this is something like -1, then you have sequential length, and you have the self-attached instance of d-k. But one thing we need to change all over here, that we need to add the batch sizes, sequential length, and we need to attach the instance of the model. So let us update this thing, and sometime guys it can be the scenario, because not all LLM, not every time any LLM gives you the correct answer. So you have to also take that into consideration, and that's why it's very much important for you to refer the official documentation while doing your respective things. So let us try to do that. So what you need to do is, let's say you put batch size, and here you have the sequential length, and you can add self .d-model all over here, and then let us try to create the respective function all over here. And we could also ask the LLM explain the contiguous function. Let us ask this. Let's say this is also kind of very much important. So let us copy this respective thing and just paste this, and you can type explain. Let us wait for the LLM to give the output. So you can see all over here, this is a method which is basically used to create a new tensor, and it's all from the PyTorch library, guys, and it is ensuring that the data is physically stored or contiguously stored in the memory according to the current tensor. And you can just see like it's a scattered pile of books, and it is trying to neatly arrange them in the shelf in the new order. And there is a view function which basically is helping or require the tensor's underlying memory. Now you have the view function, and you have the respective batch size, sequential length, and D model. After this contiguous function, it is ensuring that the memory layout is correct, and view is another function which is trying to reshape the given tensor. Pretty decent explanation, guys. I'm pretty much satisfied with it, and you can read more and do practice this with Google Colab, because it has amazing Gemini as LLM built in all over here. And then it is trying to split the num heads and the d-keys, d-keys variable, and try to, then it is transposing, and it is combining all over here. So there you have the dimension model. So basically all the view is trying to reshape this respective tensor, and this is an implicit operation, and it is trying to flatten the respective thing. So ultimately it says that the transpose changes the contextual shape, okay, and it is ensuring that the memory is matching to the contextual shape and view, and then it reshapes back to the transformer. Pretty interesting, guys. Now guys, let us create another function which is called as forward function. So we can start something like this all from here. So let us create def forward, and you can attach the respective things. So you can see Gemini is already giving us these suggestions: self qv mask equals to none, and we can just click on the tab and add the respective things. And basically what we are trying to do all over here, we are trying to apply the linear transformations. Now let us give a comment that applying linear transformation, and then we can add all over here, we can add self w dot q, and you can see all over here we are getting this option, and we can add the respective parameter that we have disclosed all over here. Now similarly, what we can do, we can click on the tab, and you can see for the respective queries and keys and the respective thing, we are applying the linear transformation by splitting the respective things. So it's all the same thing, guys. So just write heads, and you can see automatically it is going to get. Now we have applied our respective linear transformation, and there is a split heads method which we are trying to use, and these are your respective weighted query, weighted keys, and weighted values, and we are passing these respective parameters that we have disclosed all over here. Now let us perform the scaled dot product attention. So now what we can do here, we can type performing, and you can say scaled dot you can say product, and you can type all over here attention, and you can have these respective things also all over here. So you can just click on the tabs, and you can see we have this respective keyword attention props all over here, or you can give something like attention output. So we would like to give it as attention output or attention probability. I like to prefer as output, but you can keep it as probability. Now we have used self dot scaled, then underscore dot product underscore attention, and then we have the respective key Q, K, V, and mask. Now let us try to combine heads and apply the output transformation. So let us comment it also so that we remember what at every step we are trying to do. So combine heads and apply, let's say, output transformation. Then all over here what we can do is we can disclose the respective things. So we can write here output, and we can assign this to, let's say, self dot weighted output, and in this we can take the attention output all over here, and here you can see we have the respective output all over here, and we have given self dot wo, and here we can combine the respective things. So we'll not put the attention output all over here. What we can do is we can use self dot combine, and let's say this is heads, and we could add the attention output all over here in this respective method, which is your combine heads function. And finally the agenda is to return an output, so we could easily do that. And now this is the given logic for creating a forward network all over here, in which we have first applied the respective linear transformation, and we have performed a scale dot attention, we have combined heads and applied transformation. Now let us do one interesting thing, guys. Let us just copy these things and let us ask Gemini to explain in a very real world scenario example type. So explain with real world example, and also tell why okay, I think so I have by mistake I have added this, but you can just click all over here, you can redo it, and let us retype it. Explain why this step is needed with a real world example, and just click enter. And also guys, you can change your model also, you can see. But Gemini 3 is also come up with some amazing model guys with a lot of advancement, and they have increased your context tokens also. But it's like a paid version, and you need to pay to use this respective LLM. Now you can see it has started giving an output. Let us try to read it and try to understand what it is happening. Now you can see in this forward method that we have this. So self.combine heads, it's saying, imagine your research assistant has returned with the individual findings. Combine head step is like you are the lead researcher collecting all those individual things. So it's currently called forward. Okay, so I'm not able to get anything what Gemini is saying. Let's pretend like that, and let's say explain this forward method and the other respective things and the other steps involved, and why are they needed. Now let us try to see the respective output. So guys, you can see all over here, it has said that this is a part of a multi-head attention module, and we saw the given respective diagram all over here, that we were trying to apply this respective multi-headed attention after normalization, and the same thing we are trying to do all over here. Now if we go at this, it says the forward method takes your input tensors. So our tensors are Q, K, V, and there is an optional mask to produce the attention weighted output. So guys, it is basically orchestrating how different parts of the attention mechanism are working together. The first step is applying the linear transformation. Basically we call it as projections. And what it's doing is it is the self.wq, self.wk, and self.wv are nn.linear layers, and these layers independently transform the input q, k, v tensors. Now this meaning that each input tensors passes through its own dedicated projection layer. And it also says that this step is allowing the model to learn different linear projection for queries, keys, and values. And saying that it is kind of crucial because it is enabling the model to look at the same input information from 3 different learned perspectives. For instance, the query projection might emphasize features relevant for asking questions, like the key projection for indexing information and the value projection for representing the content to be extracted. Then we are splitting into multiple heads, and you can see it says after linear transformation of the output, self w.qq, self w.kk, and self w.vv are passed to the given split heads function. And this is actually what we are trying to do, is we are trying to reshape the tensor, and that's what Gemini is also saying, pretty much correct. And basically we are preparing these for the parallel processing by num heads, and for doing the independent attention mechanism for these of the respective things. Now there's an important context, guys, why I gave this prompt, because you should always remember why this respective step is needed. So whatever you are doing, guys, always ask the question why, how, and when you have to do it. And this is one of the best technique to actually learn anything, such that you will get the respective architecture, the steps involved, and that would be like pretty much most of the things that you need to do. Now let's say instead of performing one single attention calculation, you can see the input is split into num heads, into smaller parts, and each of the head can attend different parts of the sequence. And guys, also you can see it can also work on different types of relationship between the tokens. So this is basically enhancing the model's ability to capture diverse and complex dependencies in the data. And this makes attention mechanism kind of more powerful and robust. So it's just like it's saying multiple experts and each focusing on different aspects of the problem. Now you can see we have performed scaled dot product attention. So you can see we have self dot scale dot product attention, and here we have the respective attention output, where we have the self scale dot product attention, where we have Q, K, V, and mask. Now what this is doing is, this is actually where the actual attention calculation is happening, and for each of the heads that we have taken a look, each of the tensors basically, if we are talking about, and it is basically computing the dot product similarity between Q, keys, and V. So one very important calculus concept I could tell you. Let's say we have the n-dimensional plane, okay, and we want, and there's a very good question to ask, why this mathematical concept of dot product we are doing. So let's say we imagine different tensors and different planes going along to a different direction, but when we do the dot product, we are trying to find out their orientation respective to the given line. We are trying to do the dot product between Q and K, so we are trying to find the alignment of Q and K, like what is the similarity and how much they are overlapping and all those things. It's a very geometrical and kind of very important concept from 3D geometry, and you might have studied in your high school too. And if you forgot this, then do think in that perspective. And I will also repeat this again, most of the things what you are seeing mathematically being applied all over here, these are all basic calculus. So if you are not good at it, I would suggest you to take some course, study a little bit of the calculus, such that you get the analogy. Otherwise, it's just like knowing the steps, and you're not understanding the deep logic behind that. Now let us move ahead, and you can also see all over here we are getting, like, for each head it is computing the dot product similarity between the queries, keys, and these are, and scaling the scores by dividing it with the square root. And finally, we are it could be using a softmax function basically to turn these scores into probabilities, and then it applies these attention weights by the values to the weighted sum. Now this is kind of pretty much important, why this respective step is needed. So you can see all over here it says this step identifies what to pay attention to, and it is determining how much importance each element in the input sequence should place on the other elements when generating its representation. The scaling factor, or we have the square root of d comma k, it is helping to stabilize the gradients during the training. The mask is also ensuring that the model does not use the information, like for example preventing the token from attending to the future tokens or in a decoder. So when you combine heads, now this it says that we have not applied this, which will be applying, so you have to combine these respective things. So combining heads and apply the respective transformation, and you can see it says that the self scale dot product attention is going to contain the outputs from all the individual attention module that we are using, and this self dot combine heads function is it's serving as a purpose that it would try to merge these outputs from multiple heads back into the single tensor, and it is going to prepare it for the linear projection. And same concept, guys. So the core idea all over here with Gemini is trying to tell us it's that these processes are independently processed, and it's to the slice of the data, and this step is aggregating the diverse perspective which is learned by each head. Now final output, you can see also with the weighted output is another part of the linear layer. So that is something very much important. So it is taking the combined output from all the attention heads, and it is projecting the final desired output dimension. So typically you get D-model. So why this is needed? Very much important thing, because this is allowing the model to learn an optimal way and to weight and combine the aggregated information from all the respective attention heads. So this is kind of a crucial step in integrating all the learned relationships. So this is a very much important part of the feed-forward network, and this layer can especially focus on most of the relevant features across all the attention heads. So this is kind of very much important. And now let us move ahead to the next part. Now guys, let us try to revise what we have studied, because it was a bit of complex, and this is kind of very much important to recollect while we move forward. So guys, you can see all over here that we have the respective multi-head attention. Okay, and this is part of this is a class, or we can say which is defined as a subclass of PyTorch NN module. Then we have taken this D model, which stands for dimensionality of the inputs. And then we have another variable that we have passed, num heads, which is like the number of attention heads needed to split the input into. And the initialization is basically checking like if D-model is divisible by number of heads, and then it defines the transformation weights for query, key and value and output. Then what we did scaled dot product attention. So here also in this respective method we have put query, keys and value, and we had made sure that mask is equals to none. Now calculating the attention scores all over here, where you can see we have added the respective attention scores, and we have put the respective mask, and also we have tried to do the transposition. So here attention scores are calculated by taking the dot product of queries and keys, and then we are scaling the square root of any key of the dimension D of k. Then we are applying the mask. So if mask is not provided, it is applied to the attention scores to mask out the specific values. Now you can calculate attention weights and attention scores. Also you can see, so it is passed through a softmax function to convert them into probabilities that sum to the 1. And finally you are calculating the output, because the final output of the attention is calculated by multiplying the attention weights by the values v, and then you can split the heads. So you just create a function def split head, and then you create the self instance of this. So you pass this as that this given method is implied or it is considered as a part of this class's instance, and then you had passed the value x. Now after applying the attention to each head separately, this respective method has combined the results back into the single tensor of shape. We can see the shape is of the respective batch size, sequential length and D-model. Now this process helps us to prepare the result for further processing, where you can see we have created the method self q k and v, and the forward method is where the actual computation happens, and we are applying the linear transformation also. So we have the respective queries, keys and values, which are first passed through the linear transformation, and we have used the weights defined in the initialization. And finally we are splitting the heads, so the transformed query, keys and values are split into multiple heads using the split heads method. And finally we have applied the scaled dot product attention. So this is a method which is called on the split heads. Then we have the respective combined heads also, where the results from each head are combined back to a single tensor using combined heads method. Now we have also tried to apply the output transformation, where the combined tensor is passed through an output linear transformation. So guys, in my conclusion, the multi-head attention class is encapsulating the multi-head attention mechanism, and it is commonly used in transformer model. It is taking care of splitting the input into multiple attention heads by applying attention to each of the heads, and then it is combining the results. So guys, by doing so, the model is capturing various relationships in the input data at different scales. Now this is improving the expressive ability of the model. And now let us try to move ahead, and where we are going to design position-wise feed-forward networks. So guys, in this given architecture, you can see we have completed this part. Now it's time to design this. So let us go to our given collab and click on code, and we are going to get the respective things. Now similarly, let us define the class first. So let's say the class is position wise feedback network. So Just click on tab, and our Gemini is pretty much smart right now. It is able to comprehend what next should be there. Then we could define init, and let's say this is self d-model, and then we have dff. I'll explain all the parameters, guys. First, let us try to complete this, and then you can see all over here we are from the parent class. Okay, we are trying to use this respective or bind this respective parameter all over here to this respective class. So you can initialize this respective thing, and now it's time to bind the other parameters. So you can say self fc.1. You can just declare this, and this is NN linear, D model, and DFF. Then there is FC2, another variable that we have, and here also you need to do the same thing. So here what you can do is you can just type DFF. So and you can use this as D-model, and after this, what you need to do is, let us try to bind the respective things also. So self.relu equals to nnn.relu. So we are applying the relu function all over here. Then what we can do is we'll again create the forward method and forward self x, and we are returning self fc2. We are using the relu function, and inside this we are passing the fc1 with x as our respective argument. Now we'll explore all of these things. Next, let us try to decode this, what exactly I have done. So if you see the class position wise feed forward module, if you talk about here, so this class is also subclass of PyTorch NN module, and it is meaning you can see that we have applied the concept of inheritance. So guys, as you can see all over here, when we are trying to use the super keyword, what basically we are telling that we are using this respective position feed forward from the parent class, and this is going to inherit all the functionalities which is required to work with neural network layers. Next step, what we are basically trying to do is we are trying to initialize this. So we have the respective self, D model, DFF. Now, if I talk about all over here, the D model is a dimensionality of the model's input and output. DFF is a dimensionality of the inner layer in the feed forward network. Self.fc1 and self.fc2 are two fully connected linear layers with input and output dimensions as defined by our D-model and DFF. Then you can see we have the rectified linear unit all over here, so which is kind of an activation function, okay, which is introducing non-linearity between two linear layers. And finally, you can see all over here we have the respective forward method, and in this the feed forward method, if I just talk about it, the input is first passed through the first linear layer, and then we have the self relu function where the output of the fc1 is passed through the relu activation function. So relu is replacing all the negative values with 0. So this is how you are getting the non-linearity in your model. And self.fc2, which is the activated output, is passed through the second linear layer, which is fc2, and which is producing your final output. So in the summary, if I have to say, the position-wise feed-forward class is defining the position-wise feed-forward neural network, which is consisting of two linear layers with a relu activation function in between. So in the context of transformer model, guys, this is a feed-forward network which is basically applied to each position separately and identically. It is basically helping in transforming the features which is learned by the attention mechanisms within the transformer, and it is acting as an additional processing step for attention outputs. So positional encoding is basically used to inject the position information of each of the token in the input sequence, and it basically uses the sine and the cosine functions of different frequencies to generate the positional encoding. Now guys, let us move ahead and try to create the next class, which is called as positional encoding class. So guys, let us define the class with the class keyword, and let's say So our this thing has already given us, so this is a positional including NN module, and you can see we have to initialize our constructor. So def init self demodel, and let's say the maximum length what you can give all over here is giving 50. Now you can see it's giving the maximum length as 5000. What you can do all over here is you can put this respective thing. So you can put this as max length all over here, and then you can use this super keyword to inherit all the functionalities of the parent class from the NN module, and this is the respective constructor. And after doing this, what you can do, let's delete this for now. We can create one variable all over here. Let's say the variable is PE, and we can just use the respective thing. So here this is some indentation error is happening. Let us see this, why this is happening. Okay, now okay, so it says that max length is not defined. We'll try to see why this is happening. But for now, we declared one variable which we call as P, and we are using the zeros method all over here to find the maximum sequence length. Then we are putting the D model as our respective another argument all over here, and we are then creating another variable position, and we are using the function torch.arrange, and in which we have 0. Then we have something called as max sequence length. So just you can use this, okay. And after this, what basically we can do is we can declare another thing, so which is D type equals torch.float, and after this you could use the squeeze method. So that's kind of pretty much important. Now the next thing, we have to declare another variable to know the D type. So we have to use unsqueeze, so D hyphen type, and or we can just give D type all over here. So D type equals to torch, and you can use dot as a function, so you can use D type torch dot float, okay, and we can use this respective thing, and we can use the unsqueeze function. So there are some issue with the parentheses. We are going to resolve this also. Next, let us create the term called div term. And you can use the same functionality, torch.exp, torch.arrange, and in the arrange function, what you are going to do is you are going to pass the value. So let us pass the value, let's say 0, then you put the comma, and you just calculate the respective thing. So you can see all over here we have put this as D model, okay. Then we have put the D model all over here, and we have applied the float function all over here, and we have multiplied this with the respective thing, and you have the math.log. This is 1000 divided by D model. Pretty much correct, guys, but there are some of the issues coming up because these things are not being done. Let us ask the Gemini to correct the code. Okay, so let's just ask copy everything and something like resolve this code. It's showing errors, and you can give a detailed prompt also about the error. So it's very much important to give the context whenever you are writing prompt to any LLM model. So I will say showing errors at you can say max sequence length, then you can see it says D model, and showing that the given variables are initialized, and one parenthesis issue is showing. So you can see all over here I am trying to give the detailed prompt, and this is one of the best techniques to actually give the entire context. So now you can see it has started working. Let us wait for a couple of time to get the respective resolution, and you can see, so now it has given the respective solution all over here. So let us see what are the issues. So torch, 0 max sequence length, the model, position, torch arrange, unsqueeze 1, okay, div term, that was correct. Then we have used the respective sine functions, we have used the respective cosine functions, and then we created a forward function all over here with initialized with self and x. So it's also saying that x is typically batch size, sequential length, the model. So it has given further codes also which we were supposed to do, but no worries, you can see easily how this is trying to do. Now let me decode each one of them for you, what exactly we are trying to do all over here. So guys, first we define the positional encoding class, and this is also a part of the NN module under the PyTorch NN module, and it is allowing us to be created as a standard PyTorch layer. Then you can see our constructor is all over here, where we have defined the given respective variables, self, demodel, max sequential length, and we have used the super keyword, which is a very generic part when you use inheritance concepts. Now, if you are not aware about the OOPS concept, guys, I would request you to go to our channel and watch the respective OOPS concepts. Then we declared P as a variable where we have put dot.zeros, max sequential length, d.model, okay, all over here. And then we have defined these respective things. Now, if you look at D model, so this is the dimension of the model's input, as we have discussed earlier. Max sequential length, if I talk about, this is the maximum length of the sequence for which positional encodings are pre-computed. Now, if we talk about PE is a tensor which is filled with zeros, which will be populated with positional encoding. And position is also a tensor containing the position indices for each position in the sequence. Then there is a div term, which is a specific term which is used to scale the position indices in a very specific way. And finally, you can see all over here, we have applied the sine and the cosine functions, okay, and which is applied to the even indices and the cosine function to the odd indices of the PE. And finally, PE is registered as a buffer, which means it will be the part of the module's state but will not be considered as a trainable parameter. And finally, we have the forward method, which we have defined with def forward self x. So basically this forward method simply adds the positional encodings to the input x, and it uses the first x.size method, if you remember what we have used on the ASIC elements of PE, okay, which is a positional which is a kind of a tensor that we are using, and it is ensuring that the positional encodings are matching to the actual sequence of the length of x. So in a nutshell, if I have to say, this positional encoding class is adding information about the position of tokens within the sequence. And since the transformer model is lacking inherent knowledge of the order of tokens due to its self-attention mechanism, so this is the class which is helping the model to consider the position of tokens in the sequence. And the sinusoidal function used all over here are chosen to allow the model to easily learn to attend the relative positions, as they are producing unique and smooth encoding for each positions in the sequence. Now at the third step, what we will be doing is we will be building our encoder block. So let's move ahead with that. So guys, when we talk about building the encoder blocks, okay, so encoder is a part of transformer network, and this is kind of very much important. And now whenever we discuss about adding an encoder layer, it's very much important to see the architecture first and try to understand how we are building the encoder layer. And all over here, let us start with a very basic concept by creating the encoder layer. So let's define a class first, and let's say this is your encoder layer. So let's type encoder layer coming from the NN module, and then what you can do is you can define the respective constructors all over here. But let's say you have model, num heads, and DFF, and also you need a dropout. So let us add a variable dropout. Okay, now we have declared our respective parameters. Then you can use a super keyword to use all the functionality of the PyTorch NN module. Then what you can do all over here, we can use the multi-head attention method. So you can use multi head and just click on this tab. And so guys, you can see all over here we have the respective multi-head attention, and this is NN multi-head attention all over here. We have the respective D model, we have the respective num heads all over here. Now after creating this respective thing, you can see Gemini is already giving us these respective ideas. So these are the respective variables that we have created, self.attention, and this is your multi-head attention method, where you have the respective thing. Now you can see this is kind of not complete. So what we can do all over here, which you can complete this. So self.attention equals to multi-head and attention, and after typing multi-head attention you need to put the respective things. So let's delete this first, and let's try to add the respective things. So first we are going to add D model, num heads, and then what you can do is you can create the respective variables which are very much important in this context, the D model and the number heads. And you can also see we have the respective feed forward method also all over here. And if I also talk about the feed forward method, you can see that we have the respective thing, and we have the position wise feed forward method. And now when you see this respective thing, self feed hyphen forward, so we are using the position feed forward method, and in this we have put D model and DFF. Now let's just close this, and then we need to define the norm1 and norm2, and so this we have to use the NN layer from the PyTorch. So NN dot just you can click on tab. So this is NN layer norm D hyphen model, and here you can see this is NN norm2 all over here, and this is your respective layer norm on D model. Then finally we have declared this variable self.dropout, and here we can just add this respective thing NN dropout, and we could add the respective keywords all over here. Now moving forward, we need to create one respective method, which is a forward method, as we have done earlier also, to take the input X, but this time we are passing this additional parameter which is mask. Now let's just press this, and now let us create the attention output. So let us define this respective variable all over here. So this is attention output, and what we can give all over here. So this equals to, let's say this is self, and all over here self dot self we can put it up, and then we could add the respective arguments 3x and a mask. Now we have to define x also. So what we can do, we can align all over here, and one mistake we did was the indentation. Let's keep it inside, and next thing, let us define these respective parameters. So automatically automatically giving you suggestions. So if you have the idea bit about the PyTorch library, then it's kind of pretty much easier to build this respective model. And if you see, we have declared x equals to self norm 1, then we have added x plus self dropout, in which we have put the attention output. Then we have declared the FF output, and we are self-feeding this with the feed forward method and taking x as a given respective input. And now if I just also say this respective thing, so we have defined this respective variables x. So let's say if this is x self norm 2 and this is x plus self dropout, and here you can just add the respective FF output. So just declare the respective variable, okay, and finally we are returning the x. Now let me explain you, because this is one of the most important part where we are building the encoder layer. So if you could recall what we studied during the architecture of the transformer, so we paid a very close concerted look onto this. So this class is basically defined as a subclass of the PyTorch NN module, which means that it could be used as building blocks for neural networks in the PyTorch. Now we have also defined this constructor definite, and you can see I have passed these respective parameters: demodel, numheads, DFF, and dropout. And we are going to disclose all these respective parameters all over here. So if we start discussing the first thing, demodel, so basically this is the dimensionality of the input. Numheads is the respective thing where we are talking a bit about the number of attention heads in the multi-head attention. And the DFF variable, if I just say, this is your dimensionality of the inner layer in the position-wise feed-forward network. And then you have the dropout, which is like the dropout rate, which you can basically use for regularization. If I talk about the components, guys, you have this self-dot-attention all over here, and this is the respective multi-head attention mechanism applied to our transformer model. And then next thing what you can do is self-dot-feed-forward method. So this is position-wise feed-forward neural network. Okay, all applied all over here. Then you can see we have these two respective variables, norm1 and norm2. If I talk about norm1 and norm2, these are like the layer normalization, which are basically applied to smoothen the layers input. So that's, you have to understand that in context of the LLM that we have discussed. And if you see self.dropout, so this is also an additional variable where dropout layer is used to prevent any overfitting by any randomly, let's say by any, which we can consider something like when we are during the input training data set and we are putting all these zeros all over there. So for that we need respective normalization too. Okay, now if I talk a bit about self-dot-attention, now you could also see we have the last variable, that is dropout, and this is basically used to prevent overfitting, which I have already discussed right now, which could be caused by putting by the activation function to the zeros, placing it all over there at certain places. Now the same thing, it's pretty much repeated, guys, like as we have built different layers, and you could see the variables attention output we have declared and the respective thing. Now the most important part is the x variable that we have declared. So x is the input to the encoder layer, and mask is optional mask to ignore certain part of the input. So next are just the processing steps, if you could look into all over here. So in which we have self-attention, where the input x is passed through multi-head self-attention mechanism, and you are adding and normalizing it after the attention. So the attention output is added to the original input and to the residual connection, followed by the dropout as we had discussed right now. Then we are doing the normalization. So basically the output in this context of the feed-forward network, the output from the previous step is passed through the position-wise feed-forward network. We are basically normalizing it in this context all over here. This is kind of similar to the step 2 that we did, but the feed forward output is added to the input at this stage, which is basically taken in the context of residual connection. And finally, you get an output, guys. The output is a processed tensor, and it is returned as the output of the encoded layer. Now, I know it's kind of pretty much complex, guys, and you might lose a track of what we are discussing, because this is very much complex. And I would suggest you go to official library of PyTorch. Do read this official documentation, and there are amazing documentation where when you read building transformers with the help of PyTorch library, you will see that while building any LLM, or this is the basic building block that we are using. I would suggest you, there are two important concepts that we used right now. First is the OOPS concept. So if you aren't clear, check it on our channel. It's all in there. We have the PyTorch tutorial also on our channel. Just go through it, have a recap of the summary, and then come back. And then you will see how much it's getting clear. And finally, the agenda of this tutorial is to implement LLM in our course and understand how everything is getting much easier. You don't have to hard code everything. So I hope so. We are getting there now. Let us move to the next part. Now guys, let us start building the decoder block. So as you can see all over here, these are the respective decoder blocks that we have. And you can see I have applied the respective functions, and there is a software function, then you have applied the linear layer, and then there is a feed forward network, then you have the multi-headed attention, and finally you are getting the respective output after applying the multi-head attention layer and then positional encoding. So this is the respective decoder block that we need to build. Now let us start creating the respective thing. So for building the decoder block, what I can do is, let us create the same way. So let's start creating the class. So we'll start with the class keyword, and let's say this is the decoder layer. So after this, what I can do is I will start defining the respective functions. So definite, self demodel, numheads, dff, dropout. Then in this super, what I can do is I could add the respective decoder layer such that we can inherit all the respective properties from the parent class. So if you could see, this is a decoder layer. So I'll just press the tab, and you can see it is already giving us auto generating our respective prompt. But I'll repeat again, please make sure that you are aware about the steps and why you are doing it. Then we just bind this respective variable. So we are going to do self-dot attention, and here you can see we have the multi-headed attention. And let's start with demodel, okay, and now okay, and all over here. And after this, what you can do is you can start building the respective thing. So go down, and what next we can have is we can give the cross attention variable and with the respective thing, in which the variables are demodel for input and numheads. Then what next thing we could do is we could feed forward the respective thing. So for feeding the forward, what we have is, as you can see in the respective code, we have the position wide feed forward, and in this the input are the parameters that we have taken is d-model and dff. Now we are going to do some normalization. So let's see, self.norm1 equals to nn.layer norm hyphen d-model, which is kind of very basic as we had done earlier. Next thing what I could do is, let us try to create self norm1. This is nn layer norm d-model. This is self norm2 nn layer norm hyphen d-model. Then self norm3 and model. Let's close this, and after this is you can do the respective out binding. So this becomes your self.dropout and dropout. Now after this, what you can do is def forward, and you can attach the respective thing, self x ANC output, src mask, and target mask. Now Let us move ahead with the next thing. So next thing what we can do is we can take the attention output and we can attach the respective thing. Now there are 3x and the target mask as the fourth option. Now after this, what we have to do is we have to initialize or assign the x to self.norm1. So you can see it's already suggesting, kind of pretty straightforward this is, and this is giving us in a very generative way. Now we can move ahead and we can give the attention output also. So you can see there's attention output and there is self cross hyphen attention, in which you had put x as one variable, and you have the ENC output. Then you have another ENC output all over here, but next one we have is SRC mask. Now let us go down a bit, okay, and we could also initialize 1x. So what we have given all over here in the attention output, we need to initialize these or assign these x value. Then the next x is also coming from norm2, so x plus, so this is the formulation, self dropout, and then use a dropout function and keep the attention output all over here. Let's move ahead and let's try to understand the next step. So next step is you have to do is ff output self.feed forward, okay, and in which you have to assign the value of x. And after this you can see we had put the value of x all over here, and which is assigned to norm3, okay, and then this using the same formulation and dropout function, we finally are going to return the x. So this is done, and let us return x. So it's not suggesting right now, but you can do something like that. Now let us try to understand this respective layer. So first we are doing the class definition, and the class name is the decoder layer, and it is inheriting the PyTorch NN module. Now next thing is we have initialized our respective constructor with the argument d-model num leads. Now we are also going to discuss about what exactly these are. So if I just discuss about D model, is the same thing, it's the dimensionality of the input. Then you have the num-heads, which is the number of attention heads in the multi-head attention. And then you have the D-ff, which is basically the dimensionality of the inner layer in the feed-forward network. Then you have the dropout, and for the dropout we have the dropout rate for regularization. Then we have the respective components all over here, in which we have self.self-attention, multi-head self-attention mechanism for the target sequence. Then we have the cross attention all over here, and which is basically the multi-head attention mechanism that we are using that attends the encoder's output. Then you have all over here self.norm1, self.norm2, and self.norm3. It is kind of like layer normalization component, and then you have the self dropout. So this is a dropout layer for regularization, and you have the respective forward method. Now if I talk about the next forward thing, what you can do is you can use the respective method that we are generally using for each of the given layers. So in the forward, if you could see, there are a lot of formulations we had done earlier. So first, it's very important to understand what exactly is the X. So X is the input to the decoder layer, and ENC output, if I just talk about, this is the output from the corresponding encoder, which is used in the cross attention step. Now if I talk about SRC mask, then this is a source mask to ignore certain parts of the encoder's output. And then you have the respective target mask, the target mask to ignore certain parts of the decoder's input. Now we have the respective processing steps, in which we have the self-attention on target sequence. So the input X is processed through self-attention mechanism, and it is added and normalized after self-attention. And the output from the self-attention is added to the original X, and it is followed by the dropout and the normalization using norm1. Then there is a cross attention with encoder output. The normalized output from the previous step is processed through the cross attention mechanism, which is attending the encoder's output. And then we are adding and normalizing it after cross attention. The output from the cross attention is added to the input of this stage. It is followed by the dropout, and there is a normalization using norm2. Then we have is feed forward network, and this is the output from the previous step which is passed through the feed forward network. You are trying to add and normalize after feed forward. So after the feed forward output, this is added to the input of this stage. So this is very important point, guys, to remember, and following by the dropout and normalization using norm3. Now you get the respective output, in which we have the process tensor, which is returned as the output of the decoder layer. So guys, the decoder layer class defines single layer of transformers decoder, and it consists of a multi-head self-attention mechanism that attends to the encoder's output, a position-wise feed-forward neural network, and the corresponding residual connections, layer normalizations, and dropout layers. So this combination enables the decoder to generate meaningful outputs based on encoder's representations, taking into account both the target sequence and the source sequence. As with the encoder, multiple decoder layers are typically stacked to form the complete decoder part of the transformer model. Next, the encoder-decoder blocks are combined to construct the comprehensive transformer model, and which we are going to study now. So now in this code, what we are going to do is we are going to combine the encoder and decoder layers to create complete transformer of the network. So what we can do all over here, let's start creating the respective class. So for the respective class, we are going to create a transformer. So let's start with the class, and let's say this is class transformer, and this is coming from the NN module. And then we have the def init, self src vocab size, target vocab size, and d-model. We have the number of heads and number of layers. Now let's move ahead to the next part, in which we are going to use a super keyword and try to inherit the properties of our parent NN module. So if you try to write super transformer, self, and -init. So it's pretty much giving us the same code, because earlier we had done in the same way, and now our agent has got the brief idea about what we are doing after interacting with Gemini too much. Now there are a couple of variables which are kind of missing from this, so we are going to also add that. So the basic variables that we have are num heads. Okay, so you can see def heads and think so. Okay, so yeah, it has added dff. Okay, then the max sequence length, and then the dropout. And also you can see we have the num layers also. Let's cross check. Okay, now it looks pretty much fine. Now let us try to move ahead to the next step. So in the next step, what we are going to do is we are going to attach the encoder embedding all over here to this respective class. So self.encoder -embedding equals to NN module embedding, and we are trying to put the vocab size and the d-model in this. Now similarly you have to do for the decoder also. So this is like self.decoder, and you have your respective thing all over here, which is self-decoder.embedding. Okay, and in the embedding we have the respective target size, vocab size, and d-model. Then what we are basically trying to do, we are definitely trying to do some positional encoding all over here. And in the positional encoding, what we are making sure that we have the d-model, we have the max sequence length, and all those things. Now we have the respective encoder layer and the self.encoder layers, which is NN module list, and we have put encoder layer, model, and we are passing these variables like num heads, dff, and all over here. Now, after doing this, after creating this respectively, what we can do all over here is we can use the for loop, and basically we have to go in the range of number of layers. So we can do this, and after this, if you could see, we have to attach the layers also. So suggesting the same thing, self.decoder layers and in module list, then you have the respective decoder layer and you put d-model numheads, dff in dropout. Then after this, we will use again the respective for loop all over here. So for in range, number of layers, so what you can do is you can go ahead and you can attach self.fc and then dot linear model, and you can put your d model, target the vocab size all over here. Then let us try to attach the dropout part, which is self.dropout equals to nn.dropout. So this is the next thing that we did. Now after this, we can generate the mask also. So this is def generate mask and function. So after this, just add the respective things, which you can add all over here, self. Then you could add, let's say, the respective src, then the target, and all those respective things. And then you'll have to apply one conditional logic, which is src-marks, which is equals to src not equals to 0, unsqueeze 1, unsqueeze 2, and then you reassign the target mask, then you unsqueeze that, and then with the parameters 0, 1, and 3. And similarly, you need to do it. So I'll just close this one first, and then okay, the same thing, just add the tab. Okay, now next thing what you can see, we have to move ahead with the target size. So now next thing we have to do is the sequential length, and which is equals to the target size of 1. Then if I talk about in the no peak, we have the respective thing, and we are applying this one formulation, which we are using the PyTorch torch module, and says 1 minus torch, and this is a trio function in which we are using torch.ones, 1 comma sequence length and sequence length. This is pretty interesting. Now what next we could do is, after creating a no peak mask variable, now guys, there's a few things that I would like to reassess while declaring the no peak mask variable. So there are a couple of other things that we need to look into it, and these variables are, first of all, let's check for sequence length. Okay, this is we have. Then there are two types of sequence length all over here, and next thing what we can do is we can put the diagonal value, and this equals to 1. So this thing is not missing. Okay, I'll explain you later why I'm doing this, but first let's try to reassess everything. Then we are going to use the bool function. Okay, then after this, let us declare our target mask variable all over here. So you can see we have the target mask, and this equals to target mask and no peak mask. Then you are basically returning src mask, target mask. Okay, now let us try to create another function, and that is the same way, the def forward function. So let's try creating this. I don't think so it's giving us a suggestion. Let's retry this. So yeah, then in the def forward function that we have, in which we are basically taking three respective inputs, the self, src, and the target. Repeat, we are basically taking three inputs, self, src, and target. Now if I talk about self, src, and target, what we have here is the next part, and in the next part what we are going to do, we are going to declare mask and src mask and the target mask variable to self.generate mask. So we can go over here and we can just start by self.generate mask, and we are putting the source and the target. And it's time to actually declare the embedding variable that we have. So src hyphen embedded. Then you can see all over here we have src.embedded, and which is assigned to self dropout, and we have the self attention thing also all over here, and which is equal to self.positional encoding, self.encoder, and self.encoder embedding src. Now next thing we have also to declare the target embedding variable. So let's declare this target embedded and use the self.dropout function all over here, which is assigned to self.positional encoding, and inside this we have put self.decoder embedding and the respective target. Now after completing all these things, what we need to do is we need to declare another variable, that is ANC output variable, and this is equal to src embedded. Now for ANC layer in self encoder layers, you are trying to put this output to the respective thing. So you can just declare ANC layer, and you're trying to put the ANC output and the src mask. Now after completing all of these respective things, it's time for us to actually declare the output. So what we can do is we can declare the output DC output, which is equal to the target embedded, and then we use a for loop that in the decoder layer and then we access the instance of this respective class using the self variable. And after doing this, what we are going to do, we are going to assign the given decoder output to the decoder layer. So we can use the decoder layer function. So what we can write here is decoder layer, and here you have the respective output. So this is the respective output, this is the encoder output, this is src mask, this is target mask, and finally you are declaring the output all over here, and this is self.fc, and this is your respective decoder output. Finally, what I'm trying to do is I'm trying to return the output. So now this is a kind of a very this class actually was a bit larger, because here we combined everything in one. So we had the decoder layer all over here, we had the positional embedding, we have the encoder layers, and then we had the decoder layers. Now let us try to discuss each one of them. So first thing, we are creating a class called transformer, and it is actually inherited from NN module. Then we have defined the respective constructors, and you have to remember, guys, what this constructor is supposed to take the parameters. First of all, let's discuss about src hyphen vocab size. So this is the source of the vocabulary size. Then you have the target hyphen vocab size. So this is a target vocabulary size. Then you have the D hyphen model, which is basically telling you the dimensionality of the model's embedding. Then you have the number of heads, which is like the number of attention heads in the multi-head attention mechanism. Then you have the num layers, which means the number of layers for both encoder and decoder. Then you have the DFF, which is the dimensionality of the inner layer in the feed-forward network. Then you have the maximum sequence length, which is like the maximum sequence length for positional encoding. Then you have the dropout, and dropout is basically dropout rate for regularization, and it defines the following component, which we have self.encoder embeddings, where embedding layer for the source sequence. Then you have the self-decoder embedding, which is like the embedding layer for the target sequence. Then you have the positional encoding component, in which we had this is self.encoder layer, which is basically the list of encoder layers. You have self.decoder layers, which is like the list of decoder layers. Then you have self.fc also. Now guys, as you can see all over here, the next one we have the encoder layer, okay, and which is like the list of encoder layers. Then you have self.decoder layers, which is like a list of decoder layers. Then you have self.fc, which is like a final or a fully connected linear layer, which is mapping to the target vocabulary size. Then you have self.dropout, which is like your dropout layer, and it is going to generate mask method. Then you have a generate function, and it is called as self src target. So this method is used to create masks for source and target sequences, ensuring that padding tokens are ignored and the future tokens are not visible during the training for the target sequence. Finally, you have this respective forward method. Now, if I talk about this respective forward method, you have three variables, self src target. So this method is defining the forward pass for the transformer, taking the source and the target sequences and producing the output predictions. So in the input embeddings and the positional encoding, the source and the target sequences are first embedded using their respective embedding layers, and then it is added to their positional encodings. Now if I talk about the encoder layers, the source sequence is passed through the encoder layers, with the final encoder output representing the processed source sequences. If I also talk about the decoder layer, the target sequence and the encoder output are then passed through the output of the decoder layers, which is actually resulting in the decoder's output. And finally, you get a linear layer. If I talk about the linear layer, there you have the decoder's output, which is mapped to the target vocabulary size using a fully connected linear layer. And in the output, what you get, guys? In the output, you are going to get a output tensor, which is representing the model's prediction for the respective target sequences. So in the end, guys, this is the fully connected transformer module, and I'll also explain you with the architecture. So in a nutshell, if I have to say, the transformer class is bringing together various components of the transform model. Initially, we did different parts separately, but now we have combined everything, like including the embeddings, positional encoding, encoder layers, decoder layers. And it is providing convenient interface for training and inference, and encapsulating the complexities of multi-head attention and feed-forward networks. This is the implementation, and it is following the standard, very much standard transformer architecture, and it is making very much suitable for sequence to sequence tasks like machine learning translation, text translation or summarization, including masking, which is ensuring that the model is adhering to the causal dependencies within the sequences and ignoring all the padding tokens that we have. And this is also preventing information leakage from the future tokens also. These are the respective sequential steps, which is empowering the transform model to efficiently process the sequences and produce corresponding output sequences. Now, if we talk about training the PyTorch transform model, so for illustrative purposes, you can take a dummy data set and but in more of a practical scenario, let's say you have a more of a substantial data set that could be used, and this process would involve text pre-processing also, along with the creation of vocabulary mappings for both source and the target languages. Let's say the source vocab size could be 5,000, target vocab size could be 5,000, and you give D model as 512. I'll write it down so that you get a brief idea like what in the real time you can get. So let's say if I talk about those respective things, so you can give source all over here, vocab size, and this could be equal to 5,000. Then you have the target vocab size, and you can make this to 5,000 also. Then you have the D-model, and let's say this is 512. You can also make something like num hits to value 8. Then you could make the num layers equals to 6. Then you have the D-FF, which also equals to, let's say, 2048. Then you can have the max sequence length. And you could declare this to 100. and the dropout value you could assign this at, let's say, 0.1. So guys, this is kind of very much important in this context, because these variables play a very much important role for us. Now, if I talk about the respective things, now we can generate the respective random sample data. Now guys, what you can do is you can create the instance of the transformer. So let's say the given respective transformer is T, and all over here you could use a capital transformer. This is a respective class, and you could include all these respective variables that we have discussed. So source vocab size, so this is, let's make it to src. Then you have the respective D model, then you have the respective num heads, and then you have the respective num layers. All are very much important. Then you have the DFF, then you have the maximum sequence length, then you have the respective dropouts. Now let's try generating the random sample data. So let us type all over here. So let's say this includes src data, and this equals to, let's say for example, torch dot random int, and you have one src vocab size, then you have 64 also all over here, and you have passed max sequence length. So this is your respective batch size and the sequence length. Let's talk a bit about the target data also all over here. So for generating the random data, we can use the torch random int function, where I put the target vocab size, and let's say this value is passed to 64, and it should be of maximum length. Then we could start off working with the hyperparameters. Now, what are hyperparameters, guys? These are the values that define the architecture and behavior of the transformer model. For example, your src vocab size, target vocab size. So these are the vocabulary sizes for source and target sequences, and both is set to 5000. Then you have the D hyphen model, which is dimensionality of model embedding, and it is set to 512. Now if I talk about the number of attention heads in the multi-head attention mechanism, is set to 8. Then you have the number of layers. These are the number of layers for both encoder and decoder, and this is set to 6. Then you have the DFF, which is the dimensionality of the inner layer and the feed forward network, and this is set to 2048. Then you have the maximum sequence length. So this is the maximum sequence length for positional encoding, and this is set to 100. Then you have the dropout variable, which is the dropout rate for regularization, and this is set to 0.1. So for the references, the following table describes the most common hyperparameters for the transformer model and their respective values. So if I talk about the respective hyperparameter typical values which impact on performance are like D hyphen model. So it has like 256, 512, 224. Higher value increases model capacity but require more computation, as we have the num heads 8, 12, 16. So more heads can capture diverse aspects of the data but are kind of computationally intensive number of layers. So which are basically 6, 12 and 24. So more layers improve representational power but can lead to overfitting also. When I talk about DFF to 248, 496, so larger feed forward network increase models robustness. And then if you put the dropout value to 0.1 and then you put it up 0.3, so it is regularizing the model to prevent the overfitting learning rate. Then you can have 0.001 to the learning rate could be somewhere around 0.001. So basically this is impacting your conversion speed and stability batch size, which is 32, 64, 128. So larger batch size improves learning stability but requires more memory. Then we are basically creating the transformer instance all over here. So creating a transformer instance is very much important. You have named your instance as transformer and it is taking all these hyperparameters. SRC vocab size, target vocab size, D models, and num heads. Then you have the num layers, DFF, max sequential length, and dropout variable. So this line is creating instances of the transformer class and initializing it with the given hyperparameter. The instance will have architecture and behavior defined by those hyperparameters. If we talk about generating the random sample data, so SRC data, if I talk about the source data, so this is what? So these are the random integers between 1 and source vocabulary size, representing a batch of source sequences with shape like 64 and max sequence length. Then you have the target data, which is also random integers between 1 and the target vocabulary size, representing also the batch of the target sequences to the corresponding transform model and simulating the batch of the data with 64 examples and sequences of length all over here 100. Now in this entire code that we have learned right now, so this is demonstrating how to initialize transform model and generate random source and target sequences that can be fed into it. The chosen hyperparameter determines the transformer's specific properties. The setup could be part of larger script where model is trained and evaluated. Next guys, the model can be trained utilizing aforementioned sample data. However, in a real world scenario, a significant larger data set would be employed. And this is very much important because which could typically be partitioned all over here, and which could typically be partitioned into distinct sets for training and validation process. Then you have the criterion, which is you have used the NN modules and you have the cross entropy method dot loss. So in this we have the ignore index equals to 0, and then you have tried to initialize the optimizer. So in the optimizer, what you need to do is you have to use the optim variable and attach with all over here. So if I talk about the optim or the optim thing, like, so you have to use the addm method, and then you can access the parameters with the transformer.parameters method. Then you have to also give the dropout value. So if this is 0.001 and let's say the betas are in the range of 0.9 to 0.98. So these are effective thing, and you can see the variable 1e is equals to 9. So guys, let us recap one more time. So you can see we have the source vocabulary size set to 5000, we have the target vocabulary size set to 5000, then we have the D model variable which is 512, then we have the num heads which is 8, we have num layers which is 6, then we have the DFF which is set to 2048, then we have the max sequence length which is 100, dropout is 0.1, and this I've already shown you. So we are basically building a transformer instance with these respective hyperparameters. Then we are generating the random sample data. So let's say we have the source data. So we are using the PyTorch module all over here, torch.randint, and this is value as 1, source vocab size, then you have 64 maximum sequential length, then you have torch.randint, target vocab size 64 is there as an argument, and maximum sequential length. Now this code snippet is demonstrating how to initialize a transformer model and generate random source and target sequences that can be fed into it. And the chosen hyperparameters also are determining the transformer's specific structure and properties. So this setup could be part of larger script where the model is trained and evaluated on actual sequence to sequence tasks, such as machine learning translation or text summarization. So in this we have to train the model, and once the model is trained, it is utilizing the aforementioned sample data. However, in a real world scenario, a significantly larger data set would be employed, which could typically be partitioned into distinct sets for training and validation purposes. Now let us try to see in this way. Now let us create a variable called criterion. Okay. And in this, let's say this is equals to nn.cross loss, and here we can give ignoring this as something like this. let's say ignore index 0, and then we create the optimizer variable and we use the optim module. So optim.atom, and we use transformer instance that we had created, and we can use transformer.parameters. Here the learning rate I have set to 0.0001. Well, this is pretty interesting. Now what we can do all over here, then you have the optimizer all over here, and it is transformer.parameters. So you have the learning rate at 0.001, and we can also set up the betas value also all over here. So what we can do is betas, and this is something like, so all over what you can do is you can put up the beta values. Let's say the beta values could be 0.9, and this could be 0.98 all over here, and you could give the EPS values also, let's say LE minus 9. This is pretty interesting, guys. So let's say this is EPS, okay, and this is equal to LE minus 9. And next what we can do is the model will be trained and utilizing the aforementioned sample data. But however, in a real world scenario, significantly you will be dealing with a larger data set that would be employed, which you could typically partition into various processes. Now after creating this criterion, okay, and then cross entropy loss function, and you can give the ignore index as 0. After this you can create an optimizer variable, and then you can have optim.atom transformer parameters. Here you have learning rate 0.0001, beta 0.9, 0.98, and then you could train the respective thing. Now after this, guys, what you can do is you can apply actually the for loop. So I'll show you. Okay, so go down all over here. Let's start with for, let's say epoch, let's say in range 10, and let's say this is somewhat like 100. Okay, and what you can do is you could use the optimizer.0grad all over here. So you can use optimizer, that's kind of very much important. Let's delete this, and let's say optimizer.0, and we can see our Gemini is already suggesting that we should use 0.grad and then store the respective output in the respective transformer with the source data and the target data. Now what next we could do is we could actually create a loss variable. So you can see it has already suggested, and we can use criterion, and then we could store it in output.contiguous, and then we could use the view function all over here, and in this we have -1, and then you have the target vocab size. You also have the target data continuous, which is all over here, and view -1. Then you have the cross entropy loss function. What you could do is you could use the ignore index equals to 0. You can define the loss function, okay, as a cross entropy loss, and the ignore index argument is set to 0, meaning the loss will not consider targets with an index of 0. Typically it is reserved for padding the tokens. So it is defining the optimizer as Adam with the learning rate of 0.001 as specific beta values. Then you have the model training mode, and the transformer.train variable is there, which is setting the transformer model to the train mode. So this is enabling behavior like dropout that only apply during training. Now the code snippet also trains the model for 100 epochs using a typical training loop for all over here, and we are using it in the range of 100, so it is iterating over 100 training epochs. Then you can see we have also used the optimizer.0grad. Basically this is clearing the gradients from the previous iteration. And finally you have the output, so use the transformer function and you put source data and the target data. And also something I think so we have missed all over here, so excluding the last token in each sequence, and this is happening through a transformer function. So this is kind of common sequence to sequence task where the target is shifted by one token. And then you have the loss criterion function all over here, which is computing the loss between the model's prediction and the target data, excluding the first token in each sequence. And this loss is calculated by reshaping the data into one-dimensional tensors using cross-entropy loss function. Then you use the loss.backward function, which is computing the gradients of the loss with respect to the model's parameter. And then you use the optimizer.step function, which is updating the model's parameter using the computed gradients. Printf epoch plus 1, then you have the loss, and then you are using the loss.item function, which is printing the current epoch number as a loss value for that epoch. So what we have done all over here, guys, this code snippet is training the transformer model on randomly generated source and target sequences for 100 epochs, and it is using Adam optimizer basically and the cross entropy loss function, and this loss is printed for each epoch, which allows you to monitor and train training progress. In real world scenario, you would replace the random source and target sequences with the actual data of your task, such as machine translation. So guys, transformer model performance evaluation is also there. So after training the model, its performance can be evaluated on validation data set or test data set. And you could also perform that. So guys, for doing that, what we could do is we could use the transformer.eval function. Okay, and then we could generate the random data. So what we could do, we could use the val src and data, okay, and this could be equals to torch dot rand int, and we could use 1. Then we could use the respective src vocab size, and we could also put this another argument, which is 64, and then you have the max sequential length. Then we could create one more variable, which is val hyphen, and we could create it as target data, and which is basically using the PyTorch random function all over here, and the arguments are 1, the target vocab size, then 64 max sequence length. Basically the batch size and the sequential length that we are taking into consideration. Now next thing what we could do is we could type something all over here, and let's say with torch.nograd, and we could store this in, and we could use a function all over here. So this is equals to value of the source data, value of the target data, and all over here. Now next thing what we could do is, let us move ahead all over here, and next step is kind of pretty much important, and we could use this respective thing. So let's create this variable, which is like your kind of the respective thing, and let's say we are going to create the loss variable also, because that's also important, what context is being lost. So it is going to help us to monitor a lot of other things. So, and the same thing we are going to use it, val loss, and this will be equal to criterion function, and then you have the val output contiguous.view, and then you have vocab size, and then you use the view function all over here, and which is basically equals to -1. Then you are adding the vocab size, then the target data that you have, okay, and you have double columns, and you have 1. Next thing is what we can do is there's some few of the things I think so we could improve it. So in the view function, we could just use the -1 for now, and let's just enclose this. Okay, now we can directly proceed with printing it. So let's say if you're trying to print, so this could be the respective validation loss. Okay, and this could be our respective thing. Okay, so, well, loss items, if I discuss about this respective code, but this is very much important, so we have to also evaluate our transformer. So we are using the evaluation mode with the eval function. This is going to put the transformer model in the evaluation mode, and this is kind of very much important because it turns off certain behaviors like dropouts that are only used during the training. So basically it is going to generate random validation data. Now you have the val src data where you have random integers between 1 and the source vocab size, which is representing the batch of validation sources sequences with shape 64 and max sequence length. Then you have the val target data where random integers between 1 and a target vocab size, which is representing the batch of validation target sequences. And then you have the shape also present all over here. So then you have this another function that we are using with .noGrad. But this is disabling the gradient computation, as we don't need to compute gradients during validation. This can actually reduce memory consumptions, and this could also speed up our computations. Then you have this val output. Now in the val output, what you are doing is basically you are using the transformer function and you are putting val source data, val target data, and you pass the validation source data, and then you use the validation target data excluding the last token in each sequences. Now you also have the val loss variable, which we have also declared, and we have used a criterion function. So what is this? So this is kind of very much important, guys, because this is going to compute the loss between the model's prediction and validation target data. Now if we look very closely into this, we have to exclude the first token in each sequence, and that's why you can see all over here we have added this respective thing. Now the loss is calculated by reshaping that data into one-dimensional tensors, and we have already used the previously defined cross entropy loss function. And finally we are just printing it. What is the validation loss? Okay, let's say if we are giving any context, and we are not going to get that, so we need to know that, and that's why the validation loss is very much important all over here. Now this entire code snippet is evaluating the transform models on a randomly generated validation data set, and we are going to compute the validation loss, and it is going to print it. But in the real world scenario, I'll just try to say that the random validation data should be replaced with actual validation data from the task you are working on, and the validation loss can give you an indication of how well your model is performing on unseen data, which is a critical measure of model's generalization ability. Now this was a bit about transformer, guys. I hope so you would have got a brief idea onto this, and this is kind of very much important if we look very closely. So we have done a lot of complex things all over here. I would request you, if you are feeling some issues, try to rewind it backwards and try to reseed, because you would be also requiring a very sharp concentration to understand this architecture. And do visit the diagrams that I have shown you, because we are following this respective diagram, and based on that we are building it. Now I hope so after this you would have got a very clear clarity that how LLMs are basically working, what is a core part of their functionality, and that is the transformer. And after this, guys, let us move ahead with the next part. So guys, for this part of the tutorial, let us try to utilize React and also ChatGPT as our LLM, and we are going to build an amazing app with React. So for this development, all you need is a VS Code. So if you haven't downloaded, guys, VS Code, what you can do is you can go to the official website of VS Code, download, and you are going to have VS Code for these respective things. So if your operating system is Mac OS, you can click for Mac. If your operating system is on Windows, you can click for Windows. If you're using Debian or Ubuntu system, you can click all over here. So it's available, and make sure that your system architecture is x64-bit, and similarly if you want to look all over here, so you can look the specific macOS configuration, it should be 11 plus, and similarly the Debian or Ubuntu distribution based on that. Now since I have already installed VS Code, so I'm just going to open VS Code all over here. So let's open VS Code. Okay. Now the next step that all you need to do is go to your respective folder. So I'm going to close all of this thing, and let's create a new folder project such that we could use it for our React one. So click on new, then folder, and let's name this folder as React app. Okay, and try to open it with VS Code. You can drag and drop it, or you can go to the file, and there is something called open the folder, and if you click all over here in the desktop section, you're going to find out the respective thing. So let me search app, so you can see it's there. Okay, now I'm going to open this folder, and you can see our React app is open. Now, the first and the foremost, that whenever you are developing anything, let's say you're doing your software development task, I would suggest you that based on my experiences, ChatGPT does not always give you the right answer. There are some issues and errors. For example, one of my experiences were I was building microservices with Spring Boot, and I was using the library called Spring Security. Now, maybe ChatGPT is using different version of the Spring Security, and I was using latest version, and the code given by ChatGPT were all deprecated. So this might happen. Now, there is a way to resolve this given issue. Look, what we are going to do first is, let us go to the official website all over here. So let us go to our given Google Chrome, and let us go all over here and type create React app, and make sure to first of all check the version, and then you refer the official documentation and give that context to the ChatGPT. And the version of ChatGPT which I'm using is 5.2, and definitely it's a paid version, so basically it's going to give me better context as compared to the earlier ones that I had. Now if I look all over here, let's say create React app, and you can see all over here, but you can see it was given on 2022, kind of pretty much old. Now generally the latest distribution is with Wheat. So now Wheat is starting the development of is taking care of the development of React app. So go to Wheat's official website all over here, and you can see this respective thing. So let us click on the React. Okay, and we can take the reference of creating the React app with Wheat. Now let us compare both of the things first, but it has already opened the sandbox. We don't want to use the sandbox, and let us say plugin stack building. Okay, so I think so it's opening the sandbox. I don't want that. Okay, let us try to see if we have something. So it's giving me again, I think so this is going to open the sandbox only. Okay, we don't want this. So what I'm going to do is type all over here. So let's close this for now. Create React app with Wheat. And you can see you can get started with Wheat all over here. So Gemini is giving something npm create React app Wheat latest my React app, and we are going to compare the given inputs from these two LLMs. So but I am officially looking for the Wheat's official website, and let's click on the manual installation. Let's see, okay, using the npm package. So let's say this is our respective thing. So it's still not giving me the correct one. Let's see. Okay, let's try to search all over here and create React app. Let's try to search. So it's giving Azure static web apps. We also don't want that. I think so this documentation is not giving me the given respective thing. So now let us try to go on React's official website and type React app. Okay, create with Wheat. Okay, you can type this only, and let us try to see the official documentation, but it's not supporting Wheat. Let us see if we have it. Okay, so it's a very old one. Okay, now let us look into this. So npx create react app latest, but still it's not giving the Vite support. And let's go to the reactdev.com. Okay, now on this official website, I would suggest you, since you are using React version 19.2, and this is very much important for me to take into the consideration. Now, since there are multiple websites, I also sometimes get confused. So you can refer this react.dev, learn, build React app from scratch. So this is the respective URL where you are going to see the Vite reference all over here. And let's copy this, okay, and let's compare first with the ChatGPT prompt. So I'm gonna give the prompt all over here, create React app, and I'm gonna give the version number also, since version 19.2 with Vite. And let us give the official documentation reference also, and go to ChatGPT and give this prompt. You can use this link as a reference. Okay, now let's try to click enter all over here, and let us see how and compare the difference in the output from ChatGPT and Gemini. So okay, now ChatGPT started giving me few of the very important steps. First, it's making me sure that I have Node installed on my system or not. So let's check it. Okay, so go to file. Okay, there is something called view. So okay, here is view and here is terminal. Now this is a shortcut also, control plus, and then you add a backtrack. So I don't want to use that anymore. So what I can do is I'm going to open this in my respective terminal, and let's wait for a couple of times. My system hangs a little bit because a lot of projects are there in this system. So let's wait for a couple of minutes. Okay, now you can see all over here that this thing has come up. I'm just gonna look for node v-v, and it says version 22.3.0. so yes, I do have Node installed on my system. And let's go to the official website, but before that, let's go to ChatGPT and try to see what it's giving. Now it's saying npm create react Vite @ latest my react app and --template react. Now let us compare the given thing. So it's basically using TypeScript all over here, and mostly it has given the same thing, but I'm going to use this to take a reference all over here. Now let us go to the ChatGPT, and see this portion is bit missing. Now this would also work all over here, such that our respective thing is being done. I'm just going to copy this, and let's see what version we are getting downloaded. So it's going to use I think so normal vanilla JavaScript for this, and if you want to use it with TS, you can directly give TS, but I think so it is going to ask us which language we are configuring it. Now you can see we are getting some warning options all over here. So let's see. So this is unsupported engine, package create React Vite 8.2. Now let us ask GPT first, why is this we are getting? See, while you are doing the development, I would always suggest to look on the logs on your terminal. If you are not doing that, it might cause trouble in the later time. That's why you should have your documentation opened and also your respective things. So now I'm going to just copy this, explain why is this coming from React, from the log, from the terminal, I would say, while creating React app. So it's trying to explain me because the package is causing warning. Our node version is 20.19.0, and okay, but it's saying this means that the create Vite package expecting Node.js to be version this or higher, or version 22.2 or higher this, but we have the respective node version So you are using which is lower than 22.13. Okay, but it's greater than in the range. So let us ask how to upgrade to node 22.12. So it could say that we have to install it, then you can use this respective thing. So let us say you can install nvm install. Okay, first I need to check whether I have nvm or not. Let's try to okay, but we could work for this one. But let's say if I just open one more terminal and let us say, okay, let us wait for some time all over here. Okay, now all over here what I need to do is I need to first type this. So nvm is not recognized. So let us ask GPT first how do we target that thing. So I'm just gonna go all over here and type how to install nvm, and let us wait for the respective output. So it's saying some curl component. Let us try to see, and I hope so this works. So it says invoke a parameter cannot be found with matches O, and this is category. So this is a loop where you are going to get stuck. Now what if you are getting these kind of things, I would always suggest you open the official documentation right away. So let's say install nvm on Windows, and you can see we are getting, but yeah, this is official website, so we can use it all over here. And you can see it has a respective version, and this is the mirror link all over here. So download from the GitHub. So you need to download this thing. So let us wait for the respective thing. Okay, this is not opened, and I think so this is installed. Now you need to open this setup. Okay, first I would say extract this, that's much more better. So let's extract this first, and since I'm using an organizations mode, so this will ask me for this thing, but I'm suggesting you this is how you should always troubleshoot these things. So let us go to download and extract first. Okay, and after this click on extract all, and you can extract the respective things. So you can see this is installed, and then you click on it and your NVM setup is going to happen. Now I will not be proceeding with this. We are going to manage with the respective node version 22.2, and this thing because this is also going to work pretty well. Now I'm going to kill this terminal such that we don't have the overhead, and let us click on React, and let's say it is using TypeScript plus React compiler. I'm going to use TypeScript. Okay, and let us select the default options. So yeah, you can install with npm and start now. So it is going to install all the respective dependencies. It works, but certain things will be deprecated. So that's the solution I showed you guys. Please follow that, and after that you can just easily proceed with the installation. Now also by the meantime it is getting installed, I will go to the Gemini and check what prompt Gemini has given. So let us say create React app. So I'm going to type again all over here. Let's open a new browser, and in the new browser let's type very simple thing, create React app Vite. Just click all over here, and you can see it's saying npm create React app Vite latest my React app. Now if you look to the ChatGPT prompt, it is saying the respective thing. Okay, so you go above and you see all over here it is going to tell you that this is my respective thing. So here if I just see, Okay, let's go back a little bit up, and it's still not showing me the respective thing. So yeah, now you can see there is no template given all over here. So that's kind of bit of difference, and the difference in the LLMs are going to be pretty much different. So if you are using, let's say, Claude, or if you are using Gemini, or even if you are using ChatGPT, so guys, you can see there is always a difference in the context that we are seeing. So this is one of the thing. Now let us start all over here. Let us open this local host. Let's see whether our respective React app is working or not. And one very basic simple exercise what you can do is you can start clicking count 1 2 3 4 5 6 7 8 9 10, and this is the way you can check that it's working. It's pretty much fine. I would also suggest you few other developer related thing. Go to more tools and go to the developers tool. If you don't have the React developer tools, all you can do is you can download that plugin. So I would also suggest that React dev tools plug extension download, and you can just click all over here, and you can see it is available on the Chrome store. Do have it, guys. It's very much important to assess the performance and whatever the logs which you'll be getting when you are building your UI. So that's one of the another thing. Now just click all over here, and let us proceed back, and let us give another prompt. Let's say let's give GPT one of the very simple thing. Let's say first of all you give your project idea, what you want to build. Now I'll give a very detailed project prompt, and this is the most important art of prompt engineering for software developers. Give complete prompt, otherwise it is going to give you problems. Now let's elaborate our first thing. So you can say I am thinking of, let's say, building birthday wish generator, birthday wish generator with let's say very simple project. When entered, let's say, the respective data, you can wish the birthday. And next thing what you can do is and use respective, and you can say use let's say Tailwind CSS for styling, and use mock data from any online source. And I'm going to I'm feeling that this is not going to give me the correct one, which from any online website. Let's just give a very vague prompt, and I will show you how this is going to give not so much correct output. And now even if you write misspell a little bit, that's also fine. It has a great context of understanding. Model 5.2 is actually standing on a lot of benchmarks, and then I'm going to also say that you have to design each of the profiles with name, profile picture, let's say what do they do, and also we can add something like and their let's say what they do, and a little bit of description and their bio. So also explain this. So let's say if I choose month, it should give me the profiles of respective people who have birthday in that respective month. So guys, let us start all over here. And so we have given this respective prompt, and let's recollect everything. So I'm thinking of building a birthday which generation, and which when enter the respective, let's say, month. Okay, let's correct this. When entered the respective month, you can wish the birthday, use and you can use Tailwind CSS for styling, and you can also use the mock data from any online website. You have to design each profiles with the name, pick, and what they do and their bio. So let's say if I choose the respective month, it should give me the profiles of respective people who have the birthday in that respective month. Now this is pretty much fair, and I'll also say use React for building this, and I think so I have already written Tailwind CSS, so you can use React for building this app. Now I will also ask first to give me the project structure. Now let's also add more detail to it. So first, give me the project structure, and also I'll ask ChatGPT to say, and also create a separate data.js file for storing the respective birthday, storing the respective data of the people. Make sure, okay, and I have also I have missed one of the other very important thing, name profile pic, and I can add it all over here, that profile pic, what they do, their bio, and what is their birthday month. Okay, and I could also add one more functionality when, okay, for now this much is fine guys. We can add more ideas to it, but let us try to see how we are getting the respective prompt. Now let's just click all over here, and let us wait for a couple of time and give ChatGPT a little bit of time such that it does its given thing. Now you can see first the most important step, that okay, if in the assets I have got profile pics, in the components I have got three components, profile card.js, profile list.js, and month selector.js. And let's say we have the data.js, app.js, and I think so this is using tailwind.css and tailwind config.js. Now I'll also show you how this is kind of a bit different in Gemini. I'm going to open Gemini all over here too, and let's open Google Gemini all over here, and give this respective data, and you can see the Gemini output is kind of pretty different, and you can see src component. Now you can see it has given me only one component, which is profile card.js, data.js, app.jsx, and main package.js, and now it is giving me the respective data, which is pretty much a decent. And let us open this URL. Let's see whether this URL is correct or not, because we need a profile picture. So I'm just gonna click all over here. So just go all over here, and let us try to open. So, okay, fine. It's pretty interesting. Now, let's look at ChatGPT. Now, there are a couple of differences you can easily see. See, LLM is not always correct, and you can do few of the other things. You can go to your setting and always, give a context to the LLM that whatever you are telling, please cross check that and look for the official sources as the context. Now, one more important thing which I actually missed out all over here was that I have not given in this the respective GitHub links all over here, and this is one of the most important thing. So I should also ask, or with respect to the project structure or the code which is referring, and or refer to the official React documentation, or give the link also for building this. And for the project structure, you can look to the GitHub repository. So those two things I have not added. Now, what I can do all over here, so it has also given me the respective data.js, and this is my respective profile. This is all over here, and in the assets, let's try to look why it has given me the respective assets. So profile pic folder for storing the profile picture. So generally it's we are using the profile pic assets profile pic.john. Now it's not giving me any official project structure, so this is kind of pretty different. So let us do this. Okay guys, so you can see the difference all over here. Now I asked GPT to give me the profile picture from any online website, and Gemini got this, but you can see the same thing all over here. So based on your required understanding, let's say if you are using Gemini to build something, I would suggest you first grab your basics, make your basics and fundamentals very much strong, and then you can come all over here and you can try experimenting with it. But I would suggest you, LLMs are still not that much strong enough, but you can significantly improve your productivity with these apps. So I would suggest you open two most popular LLM tools and try comparing their prompts, and try some parts like ChatGPT will give correct, and Gemini might not be able to do it, or at some part, let's say your ChatGPT is giving you the correct one, but Gemini is not able to do that. So these are the respective nuances or the given things that you're going to see. Now let us start all over here. Let's start creating the folder structure. Now the folder structure here I don't find so much good, but I could see the ChatGPT one gave somewhat correct folder structure, but it's not completely correct also. See, the tailwind config.js, we need to, it is going to automatically get created when we are going to set up tailwind. So since I already know all these things, so that's why it's kind of very much important for you to know the basics. So let us create these project structures first. Let's go to src. Okay, go to my React app. This is your src, and you can see there's already a folder called assets. So and this is created with the reference to the TypeScript. Now what I'm going to do is I'm just going to go all from here, and I'm going to delete all these respective codes. Okay, we'll start from the scratch, keep these two files as it is. Now there is also, you can see tsconfig.js, app.js, tsconfig.json, but it's not been set up. Okay, and there is vite-config.js. Now I'm looking at index.html. Now it's not there. Index.css. Let's see whether tailwind is imported. No, tailwind is not imported. So what I can do next is, let's try building the project structure. So we'll refer the respective thing. So first is your components folder, then there is a data folder. Let us create these two different things. So go all over here, go in the src. In the src, create a respective, let's say, folder. Let's say this, you can make it components. And next, one file what you can make it all over here, that is your respective thing. For example, data.js file. Okay, and let us populate this respective file. For now we will only keep the three profile pictures. So I'm gonna go all over here and let us copy the respective thing from Gemini, and let's go down. Yes, now I can also ask Gemini to give more, but for now, for testing, I can use just 3. So let us copy the respective thing. Okay, so now you can see we have got with each person name, ID, role, birth month, January. And one more data we can include. Let's say, for example, birth date. Okay. So I can ask Gemini to update each one of it. Let's go to our given LLM and ask Gemini all over here, give you a prompt. So just type all over here, give updated data.js, and also add birth dates. And we can increase the count right now since we are reiterating it. So, and give 5 data also. Let's click enter and let's wait. Now we could see ID name role, ID name role, ID name role, but we have got 5, and let's say birth date is also added. Now we can update this respective thing, and you can see easily how our productivity is going to increase. Now we have got all of those things, and if let's say certain link is not opening, we can iterate that. Now for components, what I will do all over here, I'm going to go to my LLM, and this time I'm going to take the help of ChatGPT basically and ask GPT to create these respective components. So first component is your profile card.js. Since it's giving me the JavaScript file, so I might have to change the name also. So let's say this given file, let's create new file and give the given name. Now let us create another file, go all over here. Next file is your profile list.js. Now this is a very modular way of creating it, and this is actually what you should do it. So one was actually, I felt like it's not that much modular, so I used this folder structure. And now click on the new file, open it, profile list.js, and this is done. Now go all over here and let's create another component which is month selector.js. So click all over here and you can create this .js. Okay, so we have these 3 respective files. Now let's populate the code. So before populating the code, we will also assess these respective codes, try to understand what's happening. But you can see it's using Tailwind CSS, okay? And we have not installed Tailwind CSS yet, so we have to do that. But let's first populate it, okay? Let's see the output after installing it. So go all over here to respective code and make sure the first file that we have all over here is profilecard.js. Okay. Next one we have is profilelist.js. Let's populate this file also. And next file, let's say we have profile card, we have profile list, we have got. Now it's time to populate the month selector.js file. So copy this respective thing all over here and go to your month selector.js. Now this is completely correct. Okay, we can delete assets folder right now because we don't need it, or you can keep it as all over here and remove the import thing that's happening. Now go down and let's go to our respective folder Okay, so these are the respective thing. Now this is our app.js file. Now it's very much important all over here that we should render the respective things all over here. Now you can see we are using the month selector component, and then we are adding the profile list and selected month. So make sure that you need to import all over here also. So let's try to copy the given thing is app. Let's rename this first, okay, to app.jsx. And let's go all over here, and since you can see our app.jsx is empty, and right now no issues are coming up. So by default, the project structure that we have followed, ChatGPT has given us the correct you can say the prompt all over here, and we have given the correct folder path also. Now this is your respective app, okay, and this is your selected month, and this is your set select month, and this is a use state function. And finally you are using a return statement, and there is a div tag, and this is your respective thing. Then we are using h1 tag with the respective thing, and let's say this is birthday wish generator with h1 tag. Then you are using the month selector function, okay, and you can see all over here this is set selected month, and this is set selected month all over here. Now you can see what components I have actually imported all over here is profile list and month selector. So these are the two important given thing. Now I hope so you should be aware about conditional rendering and also props and also the respective use state hooks. This is very much important, such that you can understand and reassess the code also, and you can make the respective changes. But for now, since our we are creating a very prototype based thing, so this is pretty much fine. Now what we are going to do is, let us go to the next part. Okay, so let's say this is our respective data.js, and let's say this is id5, okay, all over here, and this is our respective thing. So this is pretty much done. Okay, now let's try to go do the given thing, and let's ask GPT to set up our respective Tailwind CSS. So for now, let us ask, let's say I have to install Tailwind CSS, give me the respective commands. Now there will be some issues because the data.js file that it's using, it's kind of bit different. So you can see it has ID, name, profile pic, profession, bio, or all those things. So we might need to update this given file. So that's the given context, but let's first build our given template. Now you can see all over here it has given me respective things, but we'll follow same step. First go to the official documentation and say install Tailwind CSS in React, and just it's going to the official website of Tailwind CSS. We are going to open that, and let's say while going to this official website, and you can see all over here these are the respective thing, like Laravel, Servlet, Ruby on Rails. We need to find React, guys. So Next.js, Next is there. So let's find out where we can get React router is there. Okay, so let's say if I talk about installation, it's not coming. Let's say if you go to React, okay, so you can see this is your respective thing, but we are not using React router, we are using plain React. So let us try to go with Vite. Okay, so go above, guys, and let's go to the second website, which is install Tailwind CSS with create React app, and let us see what is the respective output it's giving. So you can see all over here that this is npx create React app my project, and now it has started giving us the given thing. Now let us compare the given thing with the ChatGPT prompt. Okay, so this is the respective thing. You can directly use this all over here, but I'm showing you how the context is a bit different if we use LLM. Now first is npm install tailwind css post css auto prefixer. I think so mostly it's correct. Okay, so npm deinstall tailwind css3. Now you can see the changes have happened because this documentation is updated, and that's what most of the issues you're going to encounter with your ChatGPT. Now let us try to look for the same thing in Gemini. Now if you go to Gemini, let's say I have to install tailwind css. So give me the correct code for the same. So you can see it's giving me npm install d post css auto prefixer, which is kind of also, it's also using the old context, I think so, and then this is the respective thing. Now let us try to see the given thing, and none of them are giving because this documentation might be updated, and our LLMs does not have the respective context. You can definitely try this experiment with other LLMs also and see which is giving us the correct reference. Now if you want to avoid this thing, I would always suggest you, let's say if you are using any documentation or using any technology, so it's very much important for you to give the version number. But this thing is also going to work, which I'm going to show you how. So let us use this only for timing and show you the respective thing, but there will be the problem in versionings. That's the given thing. Now we'll check the versions also, but first go to our terminal and install this. So let's press Ctrl C, okay, so that our respective thing is terminated. Now let us go to our my React app. So let's type cd, okay, and go to my React. This is your app. Okay, we are inside our React app, and after this, what next thing we could do is we could just try to do the same thing all over here. So what's next we could do is we could just copy paste the same command. Okay, so I think so it's not copied properly. Let's copy this. So now paste this, and you can see we are getting the one given thing that this is kind of deprecated. So that's one of the things which I was telling you. So ChatGPT is not using the current context, so that's why you should always use this. But this is going to work. It's going to be completely fine. Now let us see whether our go to package.json and let's check the version number, what kind of versions we have got. So you can see all over here in TS. Okay, let's go to package.json, and it's dev dependencies, type node, tailwind css 4.1.8. Now if you go to official website of tailwind css, okay, let us check the official version of, or we can check where the respective thing. Let's go to tailwind css and version 3.4.17, or this is 4.17. This is our respective version 4.18. So kind of bit different. I'll just ask Google also what is the latest version of tailwind css. So let's type this, what is the latest version of tailwind css. So the stable version is 4.1.18, and this is the same stable version, but it is given by Gemini, guys, so that's why it's using it. Now you can see it always refer to the official documentation. So it says tailwind css 4.0 is designed for this Safari, Chrome, Firefox. Now if you want to update or upgrade it, you can type this respective command, and you can use post CSS. So in v3, Tailwind CSS package was post CSS plugin, but in version 4, post CSS plugin lives in dedicated Tailwind CSS hyphen post CSS package. So you can see they have made a changes in the documentation, but GPT is using the context of v3, and this is where most of the problems you are going to face. You are going to start a lot of troubleshooting and reiteration is what you're going to end up in, and actually that can be a little bit irritating and troublesome. So if you use this in conjunction with LLM and use this respective thing, then it's kind of pretty much easier for you to manage. Now what we are going to do, we are going to use the same thing, because either ways this is going to be correct. So after this is done, let's initialize our Tailwind CSS. So let us type this respective command, and let's click enter. Okay, now we are getting some issue. Let's see. npm Tailwind CSS npm error could not determine executable to run. A complete log of the term is not recognized as samelet function on all those things. So this is tsconfig.json, and we can see this respective thing. So this is actually not working. So now let us follow the official process. So what we are going to do is we are going to give this respective thing. Now there is an easy way to do it. You can just take a screenshot of this, okay? But I told you like some issues might come up, but it should exactly work. Most of the time it shows the correct output only. Let's ask GPT resolve this. Now let us wait for the analysis, and I'm going to also give Gemini, but Gemini I don't think so you can use too much pictures. They might because if I'm using a free version, and with the free version there are lot of issues. So we can just say resolve this. Now let us see where what we are going to see. So it's like you have actually typed a backslash, okay, and it is going to give me something like this. Now let us type this and let's see, and let us wait for the output. Still it could not determine a complete log is found all over here. Then what I'm going to do, I'm just going to copy this respective thing and go to our all over here. So this is actually not taking in anymore. So I'm going to say it's still showing me this error. So sometimes download gets interrupted. Okay, let me ask one more thing. So Tailwind should be installed under our React app which we created. Okay, and also so under React app that we have created, and also we could say something like this, or also whether it should be, or you can just say or inside the root folder. Let us wait for the respective thing. So it says Tailwind CSS must be installed in a specific React app folder. So it says yes, we are correct, and configuration checkings. So this is the respective thing. Now let us see the given thing, and it's still showing me the respective thing. So what we can do, let's force in the clean installation. So run these commands one by one. So let us retry to install it, and we are going to force this thing. So cd my react app. Let's clear the screen first, guys. Type cls. and let's redo it, and let us wait for it to get installed, and let us see current node. This is there and it requires version 20.2, and I will just say these are the, I'll give the context to the LLM and say my respective node version is this. So I think so most of, because of this only the issue is coming up. So this is the warning I'm getting because of node version. Let us try to see this thing and find our respective thing. So it says the error is very helpful as it confirms the latest version of Veach 7 slightly more recent. So let's say if I'm trying to install, but I don't think so we are going to have NVM in our system. I'll retry to do that, but it's not recognized. Okay, so we need to manually install that. Okay, and okay, this is something different. Or you can, there's one more command. So this is a built-in thing. Okay, and let's wait for the respective thing. So it has upgraded the respective thing. No installed package found in missing input criteria. Okay, so this is also not giving us the correct thing. Now since this issue is causing because I have a different version of node which is kind of this. Now I'm going to ask ChatGPT that my node version, okay, sorry Gemini, that my node version is, let's say, 22.0 all over here. So let us go and look to our respective thing. So 22.120, so mine is 20.19, and it's saying that it should be greater than 22.12.0. So what I'm going to do is I'm just going to go all over here. Okay, go to our respective Gemini and say that my node version is this. Based on this, give me compatible Tailwind installation. Now use this and let us retry to do this. But for this, what we are going to do is first let us type the, also ask Gemini that give me uninstallation command for Tailwind CSS. We are going to uninstall it and then reinstall it. So let us type this and let us wait for the given thing. So npm uninstall this and our configuration files will automatically get removed. Let's wait for this process to happen. So say it has removed, and now let's retry to run this thing. Okay, so you can see the command, respective command is all over here. So just go to our terminal and just click enter. Now let us see the respective thing. Okay, it still is showing the same thing. I don't think so this is going to work. Required node is this. This should be greater than this. So now let us look all over here to our respective folder. Okay, is this are we getting config.js file? So you can see the file is not getting created all over here. Now you can see we have reiterated couple of times, but same issue. Now if this is happening multiple times, then there is another resolution. We'll try the official documentation. I think the same error is going to come up also this time. So no, this time we got lucky and it actually happened. So sometimes also my intuition can be wrong, but mostly if this is a thing that's happening, and what I would suggest to you that you can uninstall the given package or dependency and then retry to install it. So in that fashion, it's going to be more flexible, and your given thing will get done. Now, this is a respective thing all over here, and let's move ahead. Now, let's try to configure the tailwind config.js path. Okay, so all over here, so configure the template path. So this is our import tailwind css config theme extent. Okay, now let us also look for what does ChatGPT is giving us. So it says, okay, so we didn't did the respective thing. Now if you go all the way here, okay, then this is your tailwind config.js file, and you can see there is something called module.exports, and then you have the content, respective content like src, js, jsx, ts, tsx. You have the respective theme also, and you have the respective plugins also, and these are your respective things. And what we can do all over here, we can configure this respective thing. So what I can do, I can just copy this for now, and we can so file name is tailwind config.js. So basically this is saying that what kind of files it should be allowed. So let's find a tailwind config.js file first. So ts config tailwind config.js. So you can say it's already been added. We are just going to update this respective thing. So we can see module.export, content src, js, jsx, ts, tsx, and now we are going to use Gemini is this thing that this is to be commented. Okay, you can put it as a comment all over here, so that's also fine. This is a required template. I would also suggest you to follow the respective template. Okay, so thus it looks pretty clean. Okay, I don't think so it has copied. Let's redo it. Okay, now let's go all the way here to our given VS Code, and let's repaste that respective thing. And okay, fine, this is fine only. We will delete this. So this is the type, this is a respective import, this is your tailwind.css, this is a default index.html, src, js, ts, jsx, tsx. Now we have not added theme, extend, and plugins. If you want to know more about themes and plugins, I would suggest you reading this given documentation, and believe me, tailwind css is amazing. If you start using it, you don't need to create any external file for css. You can just use the inline css with it, and there are a couple of utilities available. So if you can start learning all over here from the utility first fundamental, hover focus of the state, responsive design, how to implement dark mode, how to reuse the respective styles, or how to add the custom styles, and then you can use the respective functions and directives. Also, you can it's very interesting that you can also read a bit about customization, where you will read about configuration, content, themes, screens, colors, spacing, plugins, and presets. Now there are base styles available where you get pre-flight, you get layout, aspect ratio, container, columns, break after, break before, break inside, you have the box decoration break, and all these respective things. So try learning this, and it's pretty interesting. And now let us move ahead to the next part, and let us try to implement this respective thing. Now the next thing what Gemini is giving, let us try to look onto that. Okay, and in your index.css we have to add this respective thing. So let us find out where is our index.css. Let's import this thing. So at the top of this you need to implement the import. So click on import. So tailwind base, tailwind components, tailwind utilities, all of these things are present all over here. Now this is done. Let's move ahead to the next part. Okay, so press Ctrl save to save everything, and this is a main file. Okay, not you can see there is some issues coming up. So there is app.jsx. So why this is coming? So let's delete this, and let's try to import app. Let's do this and let's, okay, so it's saying no quick fix is available. And see this, okay, this is giving the issue. Okay, let's retry this app.jsx. So this is our respective file. So we have got the emit abbreviation. Why it's coming like this? So let's ask for the could not find declaration file module for app.jsx. So is implicitly has any type. Okay, let's print the screen all over here. Let's take a screenshot of this respective thing, and you could just snip this thing and go to our respective Gemini and ask for the respective prompt. So basically let's ask, this is a tsx file, so I'm gonna say convert this into JSX file. So let's copy this. Okay, now I think so we are going to get the correct. Okay, I don't think so this got copied. Let's copy this once again and let's, okay, so this is not happening. Okay, I think so this is kind of an old thing, and what I can do all over here instead of app, okay, this is also not getting resolved. So what we can do with respect to this is we have to create the respective folder. Okay guys, as you can see all over here, I have resolve this respective error. This is import app from app.jsx, and this is a respective thing that I have created. Now, after resolving this, let's also try to update this monthSelector.js, profilecard.js, profilelist.js with the help of your respective things. So as you can see all over here, there are more variables involved. So what I'm going to do it, guys, I'm going to just copy it, okay, and I'm going to go to my ChatGPT all over here, and I'm going to ask the GPT to update the components. Let's say give the prompt, update the components with respect to data.js, and let us wait for the output. And parallelly we can also open Gemini also. So we'll just type all over here Gemini, and you can just click all over here. And after doing this, you can see all over here we have got our respective thing. So let's just update the profile card. So go all over here in the profile card section and just copy and paste all over here. Now let's go to different section all over here, which is your respective thing, and in this given file, if you out that you have profile list also. So let's update that file also, and so that's pretty much fine. Okay. But you can see, I think so the import is not correct. We are going to redo the import, and let us see. Okay, so what I'm going to do, I'm gonna take a screenshot of this all over here, and let's say if I take this screenshot and give it to ChatGPT and say that the imports which is they are using, check the imports based on this project structure. Give about, then we can just say and give the prompt like correct the data.js imports, and after that just click enter. Now you can see all over here it's got correct, and let us try to correct the respective thing. And okay, so this is our respective correct part. Now if you could see on the profile card also, this is correct and this is also correct. Now we have corrected our respective components. Then I would just ask ChatGPT to give me updated app.jsx. Now let's go to the GPT and ask, now give the updated app.jsx based on this. So after clicking this, let us wait for the respective output. So you can see it's giving components profile list, month selector, and selected. Let's copy this for now, and let's paste all over here. Okay, so if I just go and see these respective things, so this is your app, this is selected month, use state, div style font family, month selector, profile list. Now this is pretty much correct, guys. Now this is done from our end. Let's try to run our respective app. Okay, so this app is already running. Let's first press, let's go to the respective URL and see the output. And you can see we are getting some issues all over here. So this is not correct. Let us try to say fail to import analysis. Somewhere the import is not correct. So let us go all over here. Okay, and let us try to resolve this. Okay, so if I go to the respective components folder, okay, and I think so this is coming from profile list. Okay. Now let us see the respective thing from where this is showing. Okay, so it is month selector.js, and somewhere the issue is coming up that the import is not correct. So month selector on change option months map. Okay, this is pretty much fine. Okay, and line number 38 is showing issue in this option value select month and all over. Now let us give the respective code to ChatGPT and ask for the resolution. Let us see why this is happening. Take a screenshot of this, go all over here, paste this respective thing, give the resolution based on this. So this is all over here. So let us try to find out why this is coming up. Okay, and okay, so it's saying ensure the option has a unique key. Fine, so it was a key issue problem. Let us try to update this and let us see if our resolution gets done or not. So let's see the terminal now, guys. And again, I think so we are getting issues all over here. So let's go to the respective thing. Let's refresh this. So I'll just take a screenshot of this, and somewhere this issue is happening, and we need to consistently reiterate this with ChatGPT. Resolve this, and we'll also give this picture to Gemini. Let's see what Gemini has to say. And I'll say resolve this error, and this is the respective file. Go all over here, and if this is your respective file, if you could see, just press Control A, Control C, and go all over here and paste this. Now click enter. Still the error is there. Resolve. Tell what it's saying, basically what is the error. You can just type this thing and just ask the GPT, and based on, and Gemini started thinking. So it's saying, based on the error, the image and the code provided, the issue is not with the code or logic, but with the file extension. Okay. So if you are using JSX, make sure the file is with .jsx or tsx extension. Okay, and this is the issue that's coming. So let's make this component as JSX. Okay, let's try to rename this, and let's try to rename this, and let's try to rename this also. Now still the issue persists. Okay, so if you go a bit down, then you can see still the issues are persisting. So import analysis, it was showing earlier, but right now nothing I'm able to see. Okay, now let us give this respective thing, and these are the respective issues that's coming up. So some parsing issues happening. Let us ask the GPT, why is this happening? Why is this happening? So we can give the error issue. So let's say if this is the respective screen, so you can give something like this all over here, and just paste this respective thing. I'm just only seeing the blank screen. Then we can ask for the explanation of the error also. So we can say explain this error and tell why is this happening. So guys, as you can see, our import is causing some issues. So let us go to app.jsx and see the respective imports. So these are the respective imports. Some import issue has happened because we have renamed the given file. So we need to do this. Okay, so we can do change to this, or I think so we are using the same thing all over here. So selective profile list, this is pretty much correct. Then if you see the other imports also, then yeah, we have not used the respective import all over here. So I think so some issue is happening. Vite is not able to understand this respective thing. So let us try to resolve this, and this is the given extension. So in the app.jsx, the issue is happening. It's not being able to parse it out.
Let us try this also. Okay, for now, let us see whether this issue resolves. Okay, and we can just make .jsx. These are the respective things. Now still the problem is persisting, so it's saying file react my means that tsx not found, and this is our respective thing. So what I'm going to do, let's go to our terminal first. Okay, and let's try to refresh this thing. Okay, now we are seeing certain things. Let's say if I put January, so you are going to get this out. Wow, pretty amazing, guys. This is something pretty much interesting. Let's check it for March, and you can see it has given the respective output. Now there are some of the styling things that's required. Okay, and you may also try to do for May month. We don't have any data. Let's check for June. So for June, also we are not getting anything. For July, if you could see, we are also not getting for that. In the August section also, this is not happening. This is in the October section. This is, no one is there in September. December, let's check. November, October. Pretty much fine, guys. It's been kind of pretty interesting. So also this birthday generator project we have done. It has now let us say ask it to correct the, let's say which of the following LLM is going to correct the CSS. So we're going to ask the given Gemini and ChatGPT to correct the CSS of this, and similarly we are going to give the same image to GPT and say correct the respective CSS, and make sure to give elaborated prompt, guys. And for me, what I can see is the heading birthday title generator is not giving the correct sign, or we can say it's not giving the correct alignment. So correct that, and and all over here what we can do is make the profiles also in center when we are displaying the body. Now this is pretty interesting. Let us click all over here and we copy the same thing, and let us try to paste this on ChatGPT. So after pasting this, let us see the output. So you can see certain things are coming up now in app.jsx or global styles. So you can just do this. Now let us check our global styles file. So this is on app.css. Okay, so it is like it's not relatable only, but now which file has the context, based on that only we could do it. So we need to give more idea. So you can say these are my respective files. Just go to Gemini and also to ChatGPT at the same point of time we can give our respective code. Okay, and then we can copy the same thing for profile card.jsx, copy this thing, and next thing you can just also paste it all over here. Now similarly we'll paste it here. Now correct the CSS and let us give the reference. So let's take a snapshot of this. So this is the respective thing. Here also let us give the reference. So you can see the CSS of our birthday generator project. Seems a bit incorrect, and we could also add something like it's giving with incorrect. It's giving the title completely left oriented. Also, it's giving the respective thing on the, and we can also say that it's giving the individual profiles in very left oriented alignment. So, and we can give like make the profiles in center, and also I can ask GPT and also suggest how this respective CSS would look like. Similarly, you just copy the same thing all over here and paste it to Gemini, and let us go all over here. Okay, we have pasted the respective picture. Now let us paste all over here and let us try to analyze their respective take on this. So it says that it seems that your title, birthday, profile list and the profile cards are not properly centered, which is causing the layout to look misaligned. To fix this is improve the CSS for better alignment. What you can do, you can center the heading. Okay, you can center the profile cards. You can improve the layout for mobile responsiveness. So you can do all over here. So you can see this is the body. Okay, now for the global style. Now let's take the look on the Gemini. So you can see ChatGPT is not giving that much of correct reference. Now what you can do all over here is you can ask GPT. Let's say you just tell about the problem that this is a vague response. You can just tell your issue that based on 3 files which I have shared, and you give the correct CSS. And also one more important reference you can understand respective thing. And let's wait for its respective take on this. So we can see all over here ChatGPT has started giving apologies. Well, this is pretty normal. Okay, so now global style, month selector, profile card, birthday styling, but where are we going to add these respective things? So this is going to be definitely go in the app.css file. Let's try to find this thing. So let's just replace these respective things. Now let us use these respective thing all over here. So we can go to the global styles all over here. After that there is a respective app.jsx file. So we can also update this thing. Just copy only this part and let's try to update this, and let's wait to see the respective output. So you can see all over here, this is pretty interesting. So this is like your selected month. Okay, fine. Now let us try to run our respective app. So go to terminal. Okay, we already have a terminal. Let's just slide it up. Now let us see the respective output. Okay, not much of the change. So its iteration went completely different. Okay, so now let us look for the Gemini. Let's see what Gemini is giving. So you can see all over here. So in the constant container style, and it's giving something like this. So what we can do all over here, we can replace this respective thing. Okay, and let's copy this thing first of all. So for this, just copy. Okay, and don't forget to actually use the import statement. So this is your complete app.jsx file, guys. Okay, go to your app.jsx and let's reduce this terminal size a little bit. And after this, what you can do is go over here and this is export default app, mostly looks correct. Okay, pretty much decent. Now it says that on the profile list I have to fix this thing. So let us completely agree with this and let us go to profile list and select this. So this is the container style. We can just update this. So now let us see the respective output. Okay, now this is pretty much improved. So the birthday list is coming something like this. Let's select January and you can see it's giving us pretty decent idea. Now I feel so Gemini is giving us a more correct context in terms of that. Pretty interesting, guys, pretty interesting. So this was one of our very amazing project that we did, creating a birthday generator with your ChatGPT and Gemini. So now after doing this, if you are following this tutorial, so I hope so you would have also got a brief idea that you cannot just rely on one LLM. Sometimes the reference for GPT is kind of pretty much low and you might find a better context, let's say, on other LLM. Sometimes Gemini might not be able to give, but ChatGPT will give you the correct one. So it depends, and it's still there is no hard and fast rule for that. So that's one of the respective things. Now, guys, after understanding this, let us move to the next part.
So guys, now at this part of the tutorial, we are going to discuss a very important concept, prompt engineering at the advanced level. Now, at the advanced level, it's not about asking better questions. It's actually about designing instructions in a way that aligns with how large language models process text, prioritize information, and make predictions. A prompt is not a message to a human. A prompt is just not a message. It is a control interface for a probabilistic reasoning system. Most people fail at prompt engineering because they assume model understands intent. In reality, the model only understands patterns, instructions, order, and constraints. Now, when a prompt looks correct but fails, it usually means the human intent was never made to the model. And why prompts fail even when they look correct is because whenever it's failing, let's say for XYZ reason, because humans are relying on shared context and common sense, while your model does not, and it has a different way of understanding. Now, when you say something is better, you already have a mental definition of better. The model does not have it. It guesses what is better, usually means based on the past patterns, which leads to a generic or misaligned output. And the reason prompt fails is because of conflicting goals. Humans frequently ask for outputs that are simultaneously short and detailed, and creative and factual, and also kind of casual and professional in some other ways. But the model cannot resolve contradiction until unless you explicitly tell it how to prioritize. And there is also a hidden assumption problem. Many prompts assume that the model knows the audience, the platform, the tone, the depth, or the format. If these are not stated, then the model defaults to the most statistically common version, which usually feels bland or off target. Now, let me take you to the real scenario. Imagine as a marketing manager, you are asking ChatGPT that write a LinkedIn post about AI in marketing, which we discussed in the starting of the session. So when we are saying that write a LinkedIn post about AI in marketing, to the human, this means something specific, like it's a professional tone, business audience, actionable insight, and engagement driven writing. To the model, this is just a vague content request. It responds with the generic explainer style post because that is the most common pattern associated with AI in marketing. Now, you can do the same thing and you can retry this with the chat GPT. And you're going to read the output. So I will do that one more time for you. So let us say write something like all over here. And let's say write a LinkedIn post for, let's say, AI in marketing. And we can wait for its output. And you can see all over here, it has started giving me this way. Now, let's say the same thing that we did earlier, and you can see how vague it is. There is no reference also, and it's not that much too great. Now, if I just say something like this, that let's say now the audience is, let's say, around, let's say, 3 to 7 years of experience, and the goal here is to spark, let's say, discussion, not to explain basics. And we can also give the next command that write in simple confident English. And also we can say, let's say, avoid buzzwords. And next prompt, we could give something like this. Use one strong hook. One real insight. And one end with question. And we can also see something like this, that and end with a question. Now, see the difference in the output now. So you can see we have given a lot of scenarios around our prompt, and giving a vague prompt to a model, it will become very difficult. Now you can see we truly see the challenge is not about and how are you using AI to stay ahead in your marketing strategy. So if you read this and try this respective prompt, you can increase the word count also. So depends upon model to model. This actually gives a kind of different. We'll try the same thing with Gemini and let's see how Gemini is giving us. So let's give one vague prompt. And let's click enter. So you can see, is your marketing strategy AI ready? The shift from AI driven to magic of foundation efficiency. And are you the AI select? So it's already have added. I don't know why, but these days I feel like Gemini is performing very well. they have increased their context. Now I'll give them more reference context. So let's just give this all over here and click enter, and let us wait. So you can see now it has started giving me the given thing. Now, but I'm not using this same chat, so I'll just use a different chat box because it starts taking the context with respect to your the problem that we were building earlier. Now let's give. So okay, this is pretty much wrong, and I should give the next context all over here, and we can give right a linked in post related to AI in marketing. Let's click enter, and you can see these things are coming up now. So now it has also ended up with a question. We can reiterate again and again, and the more number of reiteration, the more number of better response you can suggest. It's all about interaction with the LLM, because not at the first go you are going to get everything right. Now you can also see the output has improved because it has replaced assumptions with instructions. Now this is the most important part of your learning, and this is one of the core idea that good prompt removes guesswork from the model. Now let us discuss like how LLMs actually interpret instruction. So the large model do not read prompts the way human read instructions. They actually process text, see, and they assign probability to what comes next. This means that two things matter enormously: and instruction not gives you more instruction, clearer, specific, and closure to the end of the prompt. And if you say keep it casual at the beginning and make it formal at the end, the output will definitely be always formal. So another critical misunderstanding is the tone of the words. So humans treat words like professional, engaging, or creative or precise. For the model, these are fuzzy. One person's professional is another person's boring. So if you do not define what professional means in practice, the model defaults to safe corporate language. Now, this is one of the given thing, and also, guys, in the world of natural language processing, we discussed that transformer architecture was the core behind this technology, or the state of art models like GPT-4, BERT, or Gemini, and we can do a very good recap like how a transformer model actually revolutionized how we process and generate language. So these were one of the most important thing. And now if you go to the official website of OpenAI docs, and you can see there are a couple of other important things like prompts in the API. So it's saying that OpenAI is providing a long-lived prompt object with versioning, templating shared by all the users in the project. So this design lets you manage, test, and reuse prompts across your team with one central definition across APIs, SDKs, and dashboard. So it's saying that you can have a prompt object and you can share with your team members across your project. This is pretty interesting. So when you're using an API, let's say if Open APIs, so OpenAI's APIs, whenever you are trying to integrate that things, you can use a prompt object, and you need to create that one. Now, what are the techniques, tools and techniques if we discuss? So this comes a little bit into advanced prompt engineering. So first you have the concept of prompt caching, and next is prompt engineering, where you need to learn the strategies, techniques, and tools to construct the real prompt. Now let us try to also explore a little bit about prompt caching. So it says that the model prompts often contain repetitive content, and the system is actually trying to prompt on the common instructions that you are giving. And it says the OpenAI's API routes to the server, and it has recently processed the same prompt, making it cheaper, faster than processing a prompt from the scratch. Okay, this sounds pretty good. So prompt caching can reduce latency up to 80% and input token cost by 90%. So prompt caching works automatically on all your API requests, no code changes required, and there are no additional fees also. So this is kind of pretty interesting thing. So if you want to reduce latency and cost, you can use prompt caching. Now, if you want to use these respective things, so these are for only developers or someone who is using the API key all over here. So if you look more into this, like structuring the prompt, so there are also very much important concepts about cache hits. So if you read this, that the cache hits are only possible for exact prefix matches with a prompt, and you can also realize the caching benefits also when you place static contents like instruction and examples at the beginning of your respective prompt. And you can put the variable content, you can use a very specific thing like user specific information at the end, and it is also applying to images and the tools, which kind should be articles. So if you could see original prompt, let's say is something like this, then the cache hit happens and the cache miss happens. So now let's try to understand this pattern, because all over here what you are trying to see is these the boxes and the geometrical figures. So let's say this is in one order. Now this is in one order, but this is changing and this remains the same. This is, here is a change, here is one change, here is one change, and you just count it changing the shape or the pattern. Now if you go all over here, if you could see, this is the cache hit has happened. So so this is the respective thing you are going to see. So this is the respective the path or the context that has been taken or the LLM has retrieved. Let's say, for example, I was doing right now the React project, and when I ask a new question about AI in marketing, it's still taking the context of the respective, let's say, the React project, and half of it could take it, and some part of it got messed up. So that's what is like, it's taking up the caches, whatever the instruction, whatever you have worked on with it before, it's gonna take this, and sometime it misses it also, it does not remember the context. So that's a cache miss. Now you can also read a little bit about it, like how your given LLMs are actually working, and it's pretty interesting, I would say. So you can see the caching is enabled for prompts. So there are 1024 tokens or larger when you are making an API request. So requests are routed to the machine and you need to hash it up. So the hashing function is taking 256 tokens all over here, and the length is varying depending upon the model. Then if you could see all over here, you have to provide the prompt cache key, which is kind of important parameter. So if you just click on this, and you're going to get to the official documentation. So let's say if your example of request in the terminal is something like this. So let's say openapis.com v1-responses, and this command basically you are throwing in your terminal, and you give the content type, give your open APIs key, and let's say the model, whatever the model you are using, and the input. And then the response, you can see from the API, you're going to get response something like this. Let's try to read all over here. Okay, and if you read the response, okay, so it's like first you are going to get the ID, then the object is of type response. Time will also be there created at. What is the status? Is that respective thing is completed or not? Are there any errors or not? Are there any incoming details or not? Are there any instructions or not? Are there any max output tokens or not? Is model there or not? Okay. What is the status of ID, role, content, then the type, text, annotations, and you can also think about parallel tool calls also. So these are the respective thing. Then you have a tool choice also, tools, and there are truncation. Okay, and then it's usage, output tokens, and the respective things. So there are a lot of parameters, like if you deep dive into it, so you are going to get those respective thing. Now let's go back a little bit. This will become too much for you. If you want to interested in, then I would suggest you reading this documentation. It's very much interesting documentation, guys. Now, this is what is kind of important, and these are the three different technologies that you need to understand. That's cache lookup. So let's say when the system is checking up with the initial portion or the prefix of your prompt, so whether that cache is existed on a machine or not, you can look at to that. So let's say if I've given some context or some task to the GPT, and if the matching prefix is found, then you can see the system results are cached. And cache miss also happens, like if let's say no matching prefix is found, system is going to process your prompt and it is going to cache it afterwards. That's also kind of important. Then there is prompt cache retention. So prompt caching can either use in-memory retention policies, or it could go up to extended caching mechanisms. Then you can also look about how much extended prompt cache retention is there. So if you can see for GPT 5.2 and 5.1 codex, 5 codex, 4.1, these are the respective model. And if you're using the API, OpenAI's API key for automating anything, so you need extended prompt cache retention. So it could keep the cache prefixes active and longer, up to maximum of 24 hours. So these are basically key or value tensors, and these are representing your attention layers. Now we have discussed this in very much detail because I wanted you to understand transformer first and how you build it up, and then you come to this respective thing such that you understand the context of the LLM. Then also look onto the requirements. So it says that for caching, you should have 1024 tokens always, and in the field you can have the response objects also. And this is pretty interesting line to read, like what can be cached, like your messages, the complete message array, or encompassing the system, and what are the images to be included in this, and what are the tool usage. If you could talk about that, that's also pretty much interesting. So in this you have the context of both, let's say, array and list of available tools that you can cache it up. Now this is pretty much important, guys. I would emphasize this too much, that what are the best practices you can actually look up for. So you can structure a prompt with static or repeated content. You can use a prompt cache key parameter consistently across the request, and you can monitor your cache performance metrics also, like including your cache hit rates and all those respective things. Now you can also maintain a steady stream of requests with identical prompt prefixes. You can also minimize the respective thing cache eviction and maximize caching benefits. Now there are a couple of very much important things. See, we cannot use these automation tools or LLM models directly into your business process. That's you need to understand first. Like in banking sector, it's still not allowed. You definitely cannot use these things because there's always a risk of data exposure, and financial systems are very much sensitive to these things. You cannot do that. This means a lot of data you are exposing to the LLM. It's definitely not secure. And now if you think about these things, OpenAPI has given some FAQs for all over here, like how is the data privacy maintained for each of the caches. So you can say they have given that prompt caches are not shared between organization. Only members of the same organization can access the cache of the identical prompts. That's one of the interesting things. Now let us read another FAQ. It says, does prompt caching affect output token generation for the final response of the API? So this is pretty much important. So now it says that prompt caching does not influence the generation of output tokens or the final response which is provided by the API. So regardless of whether caching is used or not, the output generated will always be identical. And this is because only the prompt itself is cached, while the actual response is computed a new time, and each time based on the cache response. Now there is one more thing. It says that there is a way to manually clear the cache. And this is a pretty interesting question, I would say, and it says that it is not available at all. So prompts have not been encountered recently or automatically cleared from the cache. Typical cache eviction occurs around 5 to 10 minutes of inactivity and maximum 1 hour of time. So that's pretty interesting. This is an automatic process. Pretty interesting to know. Now this is for all the developers who are using the OpenAI's API key. So it says, will I be expected to pay extra for writing prompt caching? And OpenAI says that no caching happens automatically with no explicit action needed for extra cost or extra thing that you need to give. That's pretty much interesting. Now it says, do caching prompts contribute to TPM rate limits? Now if you don't know TPM rate limits, guys, let's ask the LLM only. So let's create a new chat first, and let's say explain in terms of OpenAIs. So you can refer these LLMs as much as time you can use it. So TPM stands for token per minute. Very nice. And it has also explained me the calculated strategy. Like first you take the input tokens, main system message, history plus user query. And then you have the maximum token. Okay, that's interesting. And the calculation rule is TPM equals to input tokens plus maximum tokens parameter. So input tokens plus maximum token parameters equals to token per minute. So this is the calculation rule, guys. This is pretty interesting. Also, do not blindly believe Gemini. I would also suggest you to also search this on official website. So let's say how TPM is calculated. Explain. So let's just say OpenAI. So you can just click on rate limits section, and there you can read about this. This is also pretty important to understand that you should there are things that are made by OpenAI, since you are using someone else's server and someone else's hardware resources, so you cannot abuse those API and keep on prompting. So there is a rate limit, definitely, I would say, and this helps OpenAI to actually manage load of its infrastructure, because if rate limits are not applied, then its infrastructure might get very much in trouble. So that's kind of very much important. And you could read all over here that how rate limits work. So RPM, request per day, request per minute. Gemini has given some of the basic thing, but I would suggest you to read from here. You can give the context to Gemini or ChatGPT, and then you can ask it to explain. So now if you want to read this, I would suggest you to go ahead. So there are a couple of things to look for: tokens per day, token per minute, and images per minute. So these are the respective things that are happening, or the requests per minute. So for example, let's say if we are sending 20 requests only with 100 tokens, then the chat completion endpoint, and it is going to fill our limit with RPM 20. So that's the given thing. Now guys, this was something very much relatable to all over here, but I'm going to keep it till here only. I'll give you the chance to go through this documentation. It's amazing documentation. So we'll be keeping ourselves only limited to advanced prompt portion, and the rest remaining technical aspect you can explore it. Now guys, this was all for today's tutorial. I hope so. You would have enjoyed our respective tutorial on advanced prompt engineering by Simplilearn. Thank you guys for watching this video. And also guys, I request you that do not forget to hit the subscribe button and click the notification bell icon such that you don't miss out any update from our end. Thank you guys for watching this video.